Namaskar, Suprabhatam. A very good morning to all of you. It has been a great occasion for the last 2 days under the ambit of a great promise, a dream which has come true, which is Bharata-Tirtha, in the words of Gurudev Rabindranath Thakur, where India has been a land of eternal pilgrimage in times of past, present and future, the assimilation of the great sciences of all kinds and domains, which has happened in this country, and then over hundreds and thousands of years it has disseminated to other lands, and there has also been cross exchanges of inputs and experts and great stalwarts coming from other lands. So India has always been the land of eternal assimilation. There is nothing big or small in Bharatvarsha. There is nothing which is sacred and profane in Bharatvarsha. Everything finds a place, which is the Aryan assimilation, or the idols of the Arya Rishis, the Sapta Rishis, and all the Rishis who follow him. Even scientists are Rishis because they are the carriers of the laboratories, the evidences, and the multiple explorations and iterations. So today we move on to day 3, and we have the technical session 5, and we are so happy because one of our torch bearers, the 2 torch bearers of the course that we have on the history of ancient Indian science and technology, Professor Ramesh Kumar, the Dean of Students Affairs, IIT Kharagpur. He's here, he's back because he had some issues in Kolkata. And Professor Jyotirmoy Chatterjee of the department, the school of the Center of Medical Science and Technology. Both Professor Kumar and Professor Chattopadhyay has been the torch bearer of what's happening in IIT Kharagpur, interfacing Indian knowledge systems. Professor Kumar takes care of the students, their mind, their soul, their psyche, and Professor Chattopadhyay, Professor Chatterjee takes care of Ayurveda, the biological sciences. So coming to today's session, Ayurveda, I think this is a domain in which India is hailed as the guru worldwide, because the contribution of the neurosciences, the neurophysiological sciences, the neurogenetic sciences, and its interface with the systems of yoga and tantra is a huge domain that the world is exploring in different facets and in different expressions. There are different interpretations, but ultimately the role of Ayurveda, that of herbal medicines, of alternative medicines around the world, is gaining immense popularity. And today, even in the West, alternative medicine, herbal medicine, the various domains of Ayurveda has taken strong grounds and universal acceptance. So with these humble initial words, I'll invite Professor Jyotirmoy Chatterjee, the chairperson of this session, to take over, and the entire session will be supported by the kind presence of Dr. P.C. Shukla and Dr. R. Shruti of Alwas Ayurveda Medical College to facilitate that this session becomes another brilliant one, like all the preceding sessions of yesterday and day before. And I'll conclude with this, I think you know, because of the great efforts which has come from all the former directors and the present director, who is giving us immense leadership. I'm talking about Professor Tewari and our Deputy Director, Professor Sriman Kumar Bhattacharyya. IIT Kharagpur has received a great response from the Ministry of Education in the formation of a Center of Excellence on Indian knowledge systems. So it is a national and a global news. It has gone to all the medias, and today if you check IIT Kharagpur's website, it is the first web banner. So it is really a pride and a great moment, just not for IIT Kharagpur, just not for the entire IIT system, but for Bharatvarsha. A chance that the country opens up and revives its ancient glory for all the contemporary and future applications. That's the whole thing, to connect the past and the future. So with this, I give it to Professor Jyotirmoy Chatterjee to take over the session and introduce the speakers. Just a small thing, because Professor Dr. P. Ram Manohar will be leaving after his presentation. So his questions, if there are any, may be asked right after his presentation. Yeah. So this is the only exception. Rest is fine. Namaskar. Welcome to this session. Thank you so much, sir.
Very good morning to everybody. It is the third day of the international webinar on Indology, the Bharata-Tirtha. Today we are happy that this Indian soil, which contributed to the development of the great healing system, the Ayurveda. The Ayurveda was originated, developed, cultivated, as well as it is for the first time it is linked with the modern science, that modern meets the tradition in respect to integrity, the contribution of scientific dimensions of Ayurveda. So I believe Ayurveda is not just a traditional healing art, it is the mother of knowing the human system, human biology in health and disease. It tells about the balancing of the mental and bodily structures, the modern concept. It contributes to the modern concept of mind-body medicine. It philosophically, it connotes with the Sankhya and Vaisesika philosophies, and it is linked with the different Upaveda, particularly Atharva Veda, and particularly emphasizes on the balancing of the body structure and functions. It considers the human structures from the viewpoints of tissues, the dhatus, waste or the malas, the biomaterials of dosas, and 7 dhatus also it considered. It considered as the finer aspect of the human structure, the 5 elements, Pancha Mahabhuta, the Khiti, Up, Tej, Muridvam, the earth, the water, fire, air and ether. And it talks about the balancing of the dosas with gunas. It's the first time the Ayurveda told about the psychotic aspects of the human organizations, the mental aspects, the Sattva, Raja and Tama. And it told that if we can balance these mental aspects, Sattva, Raja and Guna, with the dosa, then we can balance or we can cure the diseases. We can properly diagnose the diseases as well as treat the diseases. And Ayurvedic approach, for the first approach, it depicts the path of the most modern idea in the field of medicine, the P4 medicine, the predictive medicine, personalized medicine, participatory medicine and preventive aspect of the medicines. So WHO also talks about the or gives the idea about the P4 medicine, and Ayurveda connotes is all the ideas connotes with this kind of P4 medicine. The Ayurvedic Prakriti, concept of Prakriti. Now Professor Mukherjee will talk about the how to connote the concept of Prakriti with the modern genomics. So the development of idea of the genomics. The concept of Patha in the Ayurveda that connotes with the concept of nutrigenomics in the modern days. The Ayurvedic biological timekeeping connotes with the modern biological clock, the chronobiology, chronomedicine, the latest approach in modern medicine. So we get the idea from Ayurveda. Marmasthan and Suchibhed Chikitsa, we get the connotation with the oriental acupuncture and the most modern aspect of the medicine, the electroceuticals contributed by the electrical engineers. Ayurvedic diagnosis, the tongue diagnosis, pulse diagnosis, all are cultivated in Ayurveda. We get connotation, we get the very new connectivity with the concept of new neurological aspects, biology, biorhythmic aspects, and also we know the Ayurveda talked about the tongue diagnosis, and tongue tells about the health condition of the body. And now we understood, yes, we have another brain in the intestine. So we have two brains, one within the skull, another within the intestine. So intestine, the part of the GI tract, the tongue reflects the body structure that was mentioned by the Ayurveda many thousand years ago. So we are motivated, we are inspired, and we get the new inspiration from Ayurveda to redefine medicine from where the modern meets the tradition. In this light, we have two speakers, two eminent speakers in this field, Professor Manohar and Professor Mitali Mukherjee. First, we shall invite Professor Manohar, Professor Dr. P. Manohar, MD, BAMS MD in Ayurveda. He is the Research Director of Amrita Vishwa Vidyapeetham, Coimbatore. He received the BAMS degree in 1991 from Bharata-Tirtha University, Coimbatore, and MD in Ayurveda in 2001 from Rajiv Gandhi University of Health Sciences, Bengaluru. He has been contributing in Ayurvedic research for the last 24 years and credited more than 60 publications. Dr. Manohar has honored with Ayurveda Marg Pravartak Award in 2014 and Vaidya Sundarlal Joshi Sriti Soda Puraskar in 2015 and Bharadwaj Puraskaram Award in 2016 and Dr. C. Darakanath Memorial Award 2017. He visited most of the European countries including and the USA, UK, Canada, Argentina, Germany, France, Netherlands, Italy, Austria, Latvia, Russia, Denmark, Belgium, Singapore, Switzerland, Thailand, Sri Lanka for the promotion of the Ayurveda. So, sir, Professor Manohar, I invite you to give your speech. Thank you.
Sir, you may unmute yourself.
Please unmute Dr. Ram Manohar's
Yes.
audio.
Namaste. Can you hear? Yeah.
We can hear you. We can hear you.
So it's a great pleasure and honor to be present here today and to share my views on the topic of Ayurveda. And I'm specifically focusing on Ayurveda as nature-centered and person-centered medicine. I mean, how Ayurveda offers before us a vision of health, which is nature-centered and also person-centered at the same time. As we know, the word Ayurveda brings the focus on life itself, and it is in that context, broader context of life, that Ayurveda looks at health and disease. And for that reason, apart from, nurturing the development of medicine as a profession, Ayurveda is also dealing with life coaching and health coaching. I mean, this is most fundamental in Ayurveda. Like, we all need to be coached on how to live our lives and how to achieve optimal levels of health. It is only after these two goals are addressed adequately that Ayurveda shifts its attention to medicine, as a profession. So for this reason, Ayurveda is relevant for all of humanity, for any individual who is interested in achieving lifespan and health span. The knowledge of Ayurveda is, of utmost importance. So it's a very long tradition. I think it's remarkable that Ayurveda has survived with an unbroken continuity of tradition. And we can see in its historical evolution that it has transited from an oral to a written tradition over, centuries of transmission of knowledge, in the Guru Shishya Parampara, as we call it. So what's most interesting is that it's very difficult to look into the origins of Ayurveda. I mean, we cannot see into the mists of time. The origins of Ayurveda is lost, in antiquity, because the earliest texts that are available today are already, in a very, very organized form. And we know that the Charaka Samhita, the Sushruta Samhita, which are very early textbooks, along with some other samhitas that are available to us only in, in a incomplete version, the Dhela Samhita as well as the Kashyapa Samhita. These are all presented already in a very advanced form. They have already undergone a lot of revisions and updation. It's been impossible for historians to actually trace these texts back to their origins. So this speaks of, the antiquity of the Ayurvedic tradition. And if you look at Charaka Samhita, Sushruta, there is this triad of texts called the Brihatrayi, Charaka, Sushruta, and Vagbhada. And these names are also very symbolic, because Charaka means to always move around, Charaiveti, Charaiveti. And Sushruta means to, listen attentively, Sushrutam. And Vagbhada means, to express perfectly in speech, Vachi Bhadaha. So these three great authors, which represent the core of the Ayurvedic teachings, give to us a message of how knowledge should be acquired. Like you have to travel everywhere. That is what Charaka says. Every nook and corner of the earth should be explored. And there is a verse in one of the Samhitas also that Nadeshu Shaileshu Sarasu Chapi Vanyeshu Aranyeshu Tathashrameshu Sarvatra Sarva Parimargidavya Sarvatra Bhumir Vasuni Bhatte. So no stone should be left unturned in your exploration to acquire the knowledge of life. So that is the spirit represented by Charaka. And Sushruta is the great listener. I mean, even as you explore all over and acquire knowledge, Sushruta says you have to be open-minded and continuously keep listening and updating your knowledge. And then it is expressed in a very systematized form. And that is what Vagbhada represents. So the Brihatrayi itself, these three classical texts of Ayurveda itself represents this process of knowledge building and the spirit of, how knowledge is acquired in the tradition. So this is what we see in the old tradition of Ayurveda. And you can see that the texts are extremely kind of structured. So just like today, we have different formats of writing. I mean, research article, textbooks, letters to the editor, and thought leadership articles. So different types of writings are there in the tradition of Ayurveda also, which also kind of testifies the level of, intellectual and technical, excellence that the learned tradition of Ayurveda has reached. I'm not going into the details. We have different, this is just a glimpse of what are the types of formats they use to produce technical writing in medicine. Samhitas, which are compendiums, nikhandus, lexicon, sutras, aphorisms, koshas or glossaries, vyakhyas and commentaries, yoga sankaras or formularies, and then prakarana granthas or monographs. So the list goes on. These are some of the most major types of texts that were prevalent. And what you see here is, a representation in time and space. This is very representative. I have not put all the text. I just wanted to highlight that throughout the time period of the evolution of Ayurveda, this tradition has been extremely vibrant and active. If you look at the timelines, there has been no time when a new textbook was not written in the field of Ayurveda. There is no geographical location in the country where a new text was not created at a given point of time. So what you see is in time and space, we have a very active and vibrant tradition, which is continuously, going through this process of Charaka, Sushruta, and Vagbhada. I mean, wandering, acquiring knowledge, listening, systematizing, and then presenting it in a very structured manner. So the whole country, the entire geographical region of India has contributed across all the major timelines, new texts, new revisions. If you look at even Charaka Samhita, this is, there is a lot of updation that has happened. So if you look at the time lapse, I want to say when it comes to science from zoopharmacognosy to the importance of distinguishing between chance effect and real effect of treatment, Ayurveda was perhaps the first medical system in the world to talk about yadricha siddhi. When I treat a patient and the patient gets better, Charaka says, natra vaidyaha roga pramokshe karanam. You cannot be sure just because when you give medicine and the patient gets better, it may not have anything to do with what you did. It's a yadricha siddhi. A real effect, there is a term for real effect, pratiniyamiki siddhi. Niyamam prati means that which is repeatable. It's that which is predictable, and that which is established through tarka or reasoning. Vina tarkena ya siddhi yadricha siddhi revasa. If you cannot show a cause and effect relationship between the medicine that you gave and the outcome of the treatment, then it is dismissed as accidental effect. So I think these foundational ideas of what we call today as evidence-based medicine, you can see in Ayurveda. The effect of drug versus psychological effect, samantra, nirmantra. Vagbhada makes this distinction, that in nirmantra, a medicine works irrespective of a placebo effect. Ska nirmantre vaktir bhedokti shakti. When I am giving a nirmantra medicine, when I give haritaki to anybody, it will produce the same effect, more or less, depending on, of course, the variations that can happen individually. But a samantra medicine, it depends on who administers it, what is the mental state of the patient. So this is extremely interesting when you look at how to distinguish between drug action, how to study outcomes, karya karana bandha, how do you establish cause-effect relationships. And this openness of Ayurvedic pharmacopoeia, where we said, Jagatyevam anaushadham na kinjit vidyade dravyam. There is nothing in this universe that is not potentially having a medicinal property. So the search for medicines is an endless, journey of exploration. You can keep discovering new things. And then describing and diagnosing new diseases. This is quite fascinating. In Ayurvedic tradition, they have laid out a methodology of how to study new diseases, which Charaka calls as anukta vyadhi, that is not listed, and how you can study that based on Ayurvedic principles and how you can formulate. So all this gives us very good insight into the progressive nature of Ayurvedic tradition. I mean, it's really built, it's a knowledge tradition, it's not a system of belief. And these are some of the, development of these fundamental, thought guidelines that the whole tradition has nurtured, developing new diseases and new protocols. Charaka clearly says, if you follow only what I have written here, you're going to fail. So this is quite a fascinating description. The text is telling, don't follow what I am saying. Tasmat satyapi nirdeshe kuryad uhya swayam dhiya. Even when I have given an instruction, don't follow it blindly. Kuryad uhya swayam dhiya. Think about it, because situations change. It's the principles that you have to apply. So these are all Subudhevam Sahasrani. So the whole idea is creativity. I mean, Sushruta tells that a really trained physician, who's an excellent physician, is one who is a Swayam Kriti, who can innovate. So innovation is a driving force. Tatvathigata Shastrartho Drishta Karma Swayam Kritihi. That Swayam Krititva, where the physician becomes an innovator and contributes to the development of knowledge. I mean, this is very clearly highlighted. So new theories, new descriptions. So the list goes endlessly. It would be a fascinating exercise actually to, join all these dots and lines, I mean, that you can see in Ayurvedic, the evolution of Ayurveda as a system of healing, which is unfortunately not yet been completely attempted. This would bring a new insight into the history of medical science itself. Now, I know my time is very limited. I want to just focus on some basic features of Ayurveda. So we are always talking about individualized medicine, person-centered medicine. This, according to Ayurveda, is a very selfish way of looking at health. Because we are healthy only if nature is healthy. Ayurveda is fundamentally nature-centered medicine. So today, unfortunately, we are person-centered, individualized treatment. The individual becomes the center, the most important, focus of medical treatment. This, according to Ayurveda, is a mistake, because Ayurveda is one of the earliest systems which put this emphasis on the relationship between the microcosm and the macrocosm. In fact, Charaka says, Purushoyam Loka Samhitaha. The human is only an epitome of this whole universe. We are so interlinked. And it was Ayurveda that gave us the warning about all these pandemics and, the perennial health challenges that humanity will have to face. Tasya moolam adharmaha. When we are not living in a sustainable manner. Dharma means everything should be sustainable. What is a long-term effect? So if we burn the very house in which we are living, we are really, asking for destruction. So Ayurveda is primarily nature-centered, then person-centered, and then when it comes to person-centered medicine, Ayurveda gives this emphasis on lifestyle, diet and medicine, mind-body medicine, complex formulations, herbal, animal, chemical sources. And I have to say, Ayurveda is not just vegetarian. It's very difficult to classify Ayurveda into any one particular system or ism. So Vagbhada very clearly says, Sarvadharveshu Madhyamam. Ayurveda says all approaches are relevant and we have to use them in an appropriate manner. So it's like eating food. You have all the dishes in front of you. And all isms, all philosophies are acceptable to Ayurveda as long as they help us to achieve this goal of health and a higher state of living. So we have preventive and predictive medicine, healthy aging. So I'll just, in the next few minutes, I think I will have to conclude. So I'll quickly rush through these. The nature-centered medicine is one of the key approaches of Ayurveda. And Ayurveda says for people living in a particular locality, the medicines present there are the most suited. This is very important. This has a lot of implications for globalization of Ayurveda. We need global localization, not globalization. Ayurveda has things there. That is what we mean by nature-centered medicine. The lifestyle of a person living in a cold region and in a hot and humid region is going to be different. So the practices by themselves cannot be, transmitted worldwide. It is the principles. And when we follow the nature-centered approach, that is a great thing. And Ayurvedic understanding of the human body is from Srishti to, Vikriti or death. So Srishti Shariram, when you look at anatomy today, we are studying by dissecting a dead body. Ayurveda says that's not the right way to study medicine. If you start looking at a dead body, this is knowledge of life. You have to start by seeing the creation of a new life. Ayurvedic Sharirasthanam starts with Garbhopacharaniya. How new life emerges. You are starting the study of the knowledge of life by seeing the miracle of a new life being created. And that completely changes the way you look at life. I saw in a serial, one detective is distinguishing between a criminal and a doctor, an imposter and a doctor. This is actually from the transcript of a TV serial, which was, telecast in the US. And that detective is telling that this person is not a real doctor because he has compassion. In today's medical school, no doctor can have compassion. When you are thrown a dead body in the first year of medical science and a pile of books, the moment you lose all compassion. So this is a very incompassionate way of studying medicine. Ayurveda says, first we must know that we are born out of that whole universe. How the macrocosm becomes a microcosm. That is how the Sharirasthana begins. So this connection between the human and the external world is a very fundamental concept. Now, if you say health intelligence, we have been talking about health for all, WHO, universal health coverage. Health is not something which we can package into a bottle and distribute. So WHO gave up this slogan long ago. When we were students, health for all by 2080. In 2020, the pandemic has shown us what that means. Universal health coverage, this is the way forward. This should be the goal. Self-empowerment. Unless health becomes our individual responsibility, we cannot create a healthy society. So this is the idea that Ayurveda tells us. And then we come to person-centered medicine. Not only medicine, lifestyle, as in the introduction sir was mentioning, nutrigenomics. This is widespread. All aspects of our life can be looked at from a personalized way. And in Ayurveda, we have some of the earliest references to coding of genetic information. Charaka Samhita talks about 3 levels of genetic coding: Bija, Bija Bhaga, and Bija Bhaga Avaya. The whole body is, is presented as a blueprint, Bija. They can be subdivided into Bija Bhaga, and then there are Bija Bhaga Avayavas. We are, and different organs and parts of organs are mapped in this Bija, and depending on which Bija or Bija Bhaga or Bija Bhaga Avayava is affected, that particular organ or expression would be affected. So this is a very interesting theory that we see in Ayurveda. And I want to just very quickly mention, in Ayurveda, individualization is explained very beautifully. Ethnicity, family, inheritance, a place where you're living, time, age, and then comes the individual Prakriti. When we talk today of Prakriti, we are talking only about Dosha. But Ayurveda says Prakriti is multifaceted. In fact, what we see here is that Ayurveda has considered genetics, epigenetics, and individual propensities together to create a very beautiful framework for understanding what truly is individualization. And when you say individualization, Ayurveda says is that we cannot look at it with outside the backdrop of this common framework. Okay, so then integration of lifestyle, diet, medicine, mind-body medicine, Ayurveda. I would say that PNEI, Psycho, Neuro, Endocrine, Immunology, is a new way of explaining Manas, Vata, Pitta, and Kapha. PNEI, P is for Psycho, Manas, N is for nervous system, Vata, E is for endocrine system, Pitta, and immunology, Kapha. So this new is a rediscovery in biomolecular terms, in biomedical terms, a very old model of Ayurveda of Chittam, Manas, Vata, Pitta, and Kapha. So Ayurveda is again very open. We are not vegetarian or non-vegetarian. Everything is to be taken in an appropriate manner. Ayurveda is not just herbal medicine. And I think this is the beauty. Ayurveda is bringing different frameworks together. And I would like to conclude by saying that what is there in Ayurveda is a framework for a multi-paradigmatic approach. This is extremely important today when we look at predictive, preventive medicine. Another important aspect is healthy aging, which is a very important component of Ayurveda. I'd like to conclude by saying that today we are talking about integrative medicine, and I think we should take Ayurveda seriously. Today, integrative medicine means, bringing all other systems into one framework. This is sometimes not integration, but disintegration. Today's integration is working in such a way that into one paradigm, all other paradigms must be subsumed. That is the way integration is going. And this is where Ayurveda is going to give you a totally different approach. Ayurveda says integration should be integration of paradigms, not just integration of practices or bits and pieces of knowledge, because there you have the danger of reducing everything into one paradigm. And I must say that Charaka Samhita is one of the earliest textbooks which gave you a model for a multi-paradigmatic integration. When Charaka says Vividhani hi shastrani bhishajam pracharanti loge, in this world there are so many approaches to health that are prevalent. How do we bring them all under one framework? We bring them all under one framework by creating this Ayurvedic, integrative framework which consists of Yukti Vyapashraya, Daiva Vyapashraya, and Sattva Vajaya, which is a multi-paradigmatic framework which accepts science and also goes beyond science, which can bring together scientific and spiritual elements of healing together on one platform. So with this, I will conclude. This is just a glimpse of what Ayurveda has to offer, what it has accumulated over centuries of experience. And as we look forward into the future to reconstruct a healthy human society, I think Ayurveda assumes relevance like never before. Thank you very much for this opportunity to share some of my thoughts. Namaste.
Thanks to Thanks to Professor Monar for his excellent talk on the multidimensional aspects of Ayurveda, its origin, its development, codification of knowledge, and transition of just hearing to noting it in the document, And its most important aspect he mentioned, that integration of the paradigms, not just practice. And another very important aspect, that health intelligence, the very vital aspect of the Ayurvedic concept. We consider every dimension of health with its intelligence. So integration of multidimensional intelligence in understanding the integrated health practice or curing diseases. So I should request Professor Shukla and Shruti, Dr. Shruti, to conduct some question and answer session in respect to this.
Yeah. So thank you very much, sir. And it's a very enlightening lecture or talk from Dr. Raman. I really appreciate, and I've never seen such a wonderful explanation how a different dimension of Ayurveda. I have just very quickly two questions, if I may ask. First is that two questions. The first one is, how do you see or envision at the modern medicine or in the practitioners of modern medicine, how you think that it should be a dispensation, how they will be more accepting to the Ayurvedic principles, and how it can be incorporated into not only modern medicine but wider for wider public health. And second is very particular. How do you see Ayurveda in terms of cancer or neoplasm? What it says for that disease?
So first of all, shall I answer?
Yes, please.
So first of all, I have to say that the answer is already in the making. The Niti Aayog has come up with this new initiative of One Nation, One Health, and there's a very serious activity that is now happening to bring integrative model in India. And I'm also part of the working group, especially on education. And we have been having a lot of debates in the last many days. So I think the problem is that, there are different models of integration in different countries. And what we discovered is that the irony is that the Indian model is the most unsuitable for integration. We have a pluralistic system with legal sanction for all medical systems, but no facilitation for integration. So this is a system which nurtures conflict. It's like letting animals loose and making them, fight against each other. That is the kind of facilitation that's happening in the Indian system. So as long as this hostility is being nurtured right from the education itself, when a modern doctor is studying modern medicine, he's taught that other systems are, unscientific, and there is absolutely no attempt to introduce these subjects or to have an open mind. So I think this has to get started even from school level. We have to have a multi-paradigmatic approach to knowledge building. And another thing which I feel is we have to create a new concept of a health practitioner, a foundational course in medicine, which is not system specific. Everybody should do the foundational course so that there is no distinction between I am an Ayurvedist, I am an allopath. You should further, after that foundational course, you could specialize in Ayurveda or, in modern medicine. If that comes, then we would do two things. One is all practitioners, because they come from that one common source, they will have better respect and openness to each other. And second thing is this health practitioner itself, now what we are trying to do is after everybody specializes, we are trying to integrate. Here, integration happens at the base itself. It's already integrated. And then you specialize and then you cooperate. So anyway, it's a very difficult question to answer in a short time, but I'm just trying to give a few glimpses of what could be the solution. Now, the second question of cancer is very relevant. I'm part of a couple of initiatives. I was just an invited speaker to a trans NIH NCI conference on integrative oncology, which was this time held virtually. And I'm also a member of the Society for Integrative Oncology. which is a worldwide initiative to see how other systems of medicine can be integrated for cancer care. Now, when it comes to cancer, I have also found that there's more openness world over, because the disease is so challenging and much more unmet needs in cancer than any other disease. So I want to tell one experience. There is a doctor here in Kerala, the first medical oncologist, Dr. C.P. Matthew from Kottayam. And if I just narrate in 1 or 2 sentences what he's doing, I think you can understand the scope of what Ayurveda can do in cancer. So he's the first qualified medical oncologist in Kerala. He was the head of medical oncology in Kottayam Medical College and retired as vice principal. During his career there, he found that one of his patients who had terminal lung cancer and who he said would live maybe for a couple of weeks came back, shocking him, much better. And although he was not completely cured, he lived for 8 years, after that encounter, and through the use of Siddha medicine. So usually these kind of things happen. Modern oncologists just, brush it aside. They don't take it seriously. But this oncologist was very curious. He explains how he went out of the way to go and study under Siddha Ayurveda physicians, even as I was practicing medical oncology. And slowly he incorporated this into his practice. So today he is one of the most sought after modern oncologists who has integrated Ayurveda and Siddha into this, practice. What he says is an integrative approach is the best. He says a lot of time you can avoid chemotherapy and radiation, but certain contexts that would also be helpful, especially in very advanced tumors. If you are, debulking the tumor, reducing the tumor burden, and then introducing Ayurvedic medicines, it works better. Let me conclude by saying the Tridosha theory explains to you what is cancer. Cancer is proliferation of these cells, multiple divisions. This is Vata. Vata is that which causes the cells to multiply. But it accumulates, and that is Kapha. Kapha causes the accumulation. So as long as cancer is working in Vata and Kapha mode, it is silent and it's slowly developing. And it is when Pitta manifests. So cancer is a Tridosha disease. It is at a certain point that when Pitta comes into the picture, that cancer becomes aggressive. And so Ayurveda says that we must deal with this disease also at a very early stage. When it is still in the Vata Kapha stage, you can, and this is the reason why chemotherapy and radiation also sometimes is harmful, because they provoke Pitta in the cancer. You can see once chemotherapy is done or radiation is done, even though there may be an initial, relapse, the cancer comes back with greater, vehemence. This is because Pitta is now provoked. So the whole thing in Ayurveda is about how not to provoke Pitta in cancer. And if you do that and you start very early, I think we would be able to reduce a lot of morbidity and mortality. And we hope that such an integrative approach can be created. It's one of the first areas where we could do integrative.
Okay. Thank you very much. Thank you. I really appreciate your... Yes.
I have one small sir,
So I think I will have to...
hello?
Yes.
No, just one question, sir. Actually, Ayurveda is
Yes.
the only medical system in the world which integrates some philosophical concept. The Vaiseshika, Sankho, this philosophy.
Sir, you are not audible, sir.
I'm trying to understand. Yes. The Ayurveda is the only medical system which integrates some or embeds some philosophical concepts. So without philosophical integrity, no system can achieve some value system. So when we talk about the empathy or sympathy for the patients, then value system is important. So can you say something about in the practice or in research and practice, how to integrate some value system and what Ayurveda shows us? What we learn from that?
No, I mean, Ayurveda is based on the concept of compassion, empathy. In fact, Charaka Samhita says that is the true, characteristic of a healer. I just like to narrate a story very briefly. Nagarjuna was a great healer. He wanted 2 disciples. So he decided to test. He wanted a disciple. So some people came up. 2 of them came and he tested them. So he told, you have to make a good rasayana. I'll show you how to do it. and you just make it yourself and come back. So two of them comes back, one person comes with the rasayana, the other person comes empty-handed. And Nagarjuna looks at the rasayana and says, very well made, you're really understood how to do it. But then he asked the other person, why did you not make a rasayana? So he said, the moment I went out, I saw a very old person who was, struggling and asking for help. And so I just could not ignore him. So I had to actually help him. And by the time, I attended to his needs, there was no time to make this. And now Nagarjuna said,
Thank you, sir.
I choose.
Thank you,
I
sir.
choose the second person.
Thank you. Thank you, sir. Thank you, sir. Yes. So next speaker, I'm kind of next.
Okay, so I think I must take leave. Thank you, namaste.
And
So our next speaker, Professor Mitali Mukherjee, the Chief Scientist at CSIR Institute Genomics and Integrative Biology with notable achievement in the field of human genomics and personalized medicine. She holds a doctoral degree in bacterial molecular genetics from the Indian Institute of Science, Bangalore. One of her most influential mentors has been Dr. Somir Kumar Brahmachari, the former Director General of Council of Scientific and Industrial Research. She is best known for initiating the field of Ayurgenomics, integration of the genomic concepts or Ayurveda, Ayurgenomics, in collaboration with her colleague, Dr. Bhavna Prasad, MD in Ayurveda, under the mentorship of Professor Brahmachari. She is the recipient of Shanti Sarup Bhatnagar Award 2010, and her group is for the first time published the findings of the Ayurgenomics in the prestigious journal, one of the prestigious journal of the world, the Proceedings of National Academy of Sciences. So now I would like to request Professor Mukherjee to start her deliberation. Please unmute, please. Professor Mukherjee, please unmute your. Yes.
Am I audible? Hello, am I audible?
Yes, madam. You are audible. You are. Yeah. Yes.
It's actually an honor to be speaking in such an august audience. I am from this very different area of genomics, but I've been trying to understand the basis of Ayurveda to modern sciences approach. And I'm very humbled by looking at the extent of work which is going on in IIT Kharagpur. I've been hearing some of the lectures, and it's a really wonderful initiative which IIT Kharagpur has taken. And also, my previous speaker has made my life much more easier. Normally, when I speak in an audience, then I have to kind of pitch the work why I am doing, being a modern sciences person. But I think this is the most comfortable audience where I am getting to speak. So, as you mentioned, I am going to present a work which I and Dr. Bhavna Prasad, we've been working together for the last 2 decades. It was initiated under the mentorship of Professor Brahmachari, and I'll just try to kind of elucidate in modern language what principles of Ayurveda and why we need it. Why, as modern researchers, it's not that only we want to understand Ayurveda, but also if we understand that, how it can actually augment what are the developments which are happening in precision medicine is what I would like to kind of speak about in the next couple of minutes. So, as we all know, the global burden of diseases is increased, and this is the data of the WHO study which concluded in 2017. And one very important thing which came up across the study across all around the world is that the burden of non-communicable diseases is on the rise. And even though we've been able to manage to live longer because of lots of interventional possibilities, the health longevity overall has reduced by 10 years. So that means we are living for 10 more years more, but not in a good state of health. That actually is making the medicine quite unaffordable. In that context, many aspects are also coming up. One of the major things is that most of the medicines which are in use are based on population averages, and there is a lot of it related to the individuality of the person, and that's why one major initiative, the Human Genome Project, was taken up to understand how people differ at the genetic level. And if one is able to kind of layer other expression information on the basic genetic makeup, then one could kind of tailor a person's medicine. So there's been a lot of advancements after we got the Human Genome Project, and now people have moved on to another phase, which is called as the Precision Medicine Initiative, where the idea is that can you actually capture the spatio-temporal expression of a person using a lot of multi-omic technology, sensors and all, and try to integrate this information in a spatio-temporal dimension to be able to understand how a person responds to a particular trigger, because clearly it is evident that not everybody with the same kind of an exposure kind of response similarly. Idea is how do we uncover the pattern. So this is like creating a GIS map of a person in a spatio-temporal dimension and trying to then understand the network which connects and which gives people different responses. And then looking at the pattern, will we be able to develop some predictive models to be able to then recommend a tailored therapy. So that's the move for the precision medicine initiative, and millions of data points are being captured across the world to be able to understand this. But this is fraught with a lot of challenges. That's because the human genome, once it got sequenced, we got to know that there is no one reference human genome. Even between related individuals, we might differ in 1 million places. And when we catalog such kind of variations all across the world, huge number of variability is seen even in the letters of 3 into 10 power 9. Coupled to that, now we know that we are also colonized by microbes. They contribute to 10-fold more number of genes than in the human. So that's why human and microbiome now constitute what's the human. And along with that, then we are shaped by environment, migration, admixture, selection, dietary, cultural factors. As a result of which, the combinatorial possibilities even within a population is immense, and one does not have any idea about how you will define a health or healthy state of an individual. So when we, in the modern perspective, define health, it is always in reference to a disease state, but from the health state, we really do not have a definition of what comprises health state. So if I am not diabetic, I am healthy with the perspective of diabetes, but not that I would not know whether I am healthy per se and how much healthy I am. Right? The other thing which also is coming up is that even if you know a mutation, for example, sickle cell is one gene which causes a mutation, but a person with a sickle cell anemia can have variable outcome. The person can have a stroke, can have a pain, can have a hemolytic crisis, can have bone infarction. So one cannot actually predict the person with a mutation what is the consequence, because that also plays out differently in the presence of other genetic factors or environment. So as a result of which, this is only for a monogenic disorder, but when we talk about complex diseases, and this is true for many diseases, that every one has a genetic makeup which makes us maybe predisposed. Then we are impacted by environment, but that plays out differently in people. As a result of which, individuals might progress to disease severity, different levels of progression, and so even though there are converging themes in a disease, what would be playing out in which individual in which manner becomes a challenge to understand. Then the other thing is that if we are talking about population and if we are talking about precision medicine, then if the medicines are all population based, it is coming out that every medicine is not effective in every individual. For example, this is a prominent thing called NNT, number needed to treat. So if you give a medicine to so many people, only the blue one is actually having an effective outcome. These are out of randomized trial information which has been accumulated over many diseases, and doctors actually use this for understanding how effective the medicine is going to be. And clearly, it shows that there is a massive inter-individual variability. So, if the practitioner sees the same disease, the treatment outcome is not similar. And now, what individuals are moving to, and what Dr. Ramanu has also alluded to, is that people are shifting to from RCT to N of 1 trial. That is, one individual becomes his own control, and then the doctor and patient have kind of calibrate the medicine for that person. And if you aggregate that information, then you will be able to maybe have a medicine appropriately given. So in this context, India is very diverse and it has accumulated a large number of populations. It's a huge global melting pot of human diversity where there have been settlements in different parts of the country at different time periods with invasions from different places and mixture. As a result of which, if you look at India, then it's a huge tapestry of linguistic lineages. We have Indo-European speaker, Dravidian speaker, Austro-Asiatic, or Tibeto-Burman speakers all residing in different parts of the country. We've got all lineages which can be defined by morphological criteria. Coupled to that, we have huge number of communities with endogamy, and as a result of which, if we want to also personalize the medicine, we need to first understand what our population comprises and whether if we develop such kind of a medicine, is it likely to be useful to all. So this was one of the initiatives which I was involved. This was led by Professor Bhattacharyya. It was called as the Indian Genome Variation Project, where we first got out to understand how in India we are related to each other. Are we related by speaking the same language? Are we related by residing in the same geographical region, or ethnicity? What binds us? And this is a huge project where it went from 2002 to 2007. Lots of CSR institutes along with ISI participated, and we got to make the first comprehensive genetic landscape of India from the perspective of genes which are relevant in diseases. And we got to know that Indian populations can cluster into 4 to 5 major groups, but it is not that if you speak the same language, you are related to each other. There are certain rules or certain guiding principles based on which we can actually now predict if an individual is from some part, where is the ancestry coming from. And we also get to know how we are related differently to the Caucasians or the Chinese or the Japanese, or how we have certain populations which are innate, which are indigenous in India. So this was I just and if you overlay lots of other kinds of information, we also see that variations in genes which confer differences, for example, in susceptibility to HIV, are also linked to the ancestry relation. For example, this part of the India is more admixed with the Caucasian, and Caucasians are known to be more protected to HIV because of certain variations in them, and that's what the footprint we also see in the Indian population map. Or populations which reside in malaria endemic region have differences with respect to certain genes which give them differences. So that means it actually shows that even the genetic makeup within an individual needs to be contextualized by the geography, as Dr. Ramana was mentioning, before we get on to also embark on such studies. So not only we need to know about the genetic makeup, we need to actually know how we are related and how admixture has happened. In this case, I would just like to mention that this kind of a study which we got is very reminiscent of the theme of this meeting, where you started with Sri Rabindranath Tagore's poem about Bharata-Tirtha. This is the English translation of that, but what was very lucidly recited in a poem, we actually saw it playing out when we had this Indian Genome Variation Project, where we not only see that India has its own makeup, but it also is now a population which has been a melting pot of human diversity, and any study which is done in India could actually be relevant to different parts of the world. Now, coming to that, so there is an ethnicity, there is a geography, but then precision medicine, that's what is the topic. And this is what is called a C4 medicine, which is predictive, personalized, preventive, and participation. This kind of a medical system which people are moving towards now is not new to India. In fact, recently it's also been acknowledged in Nature Outlook, where they say that India, the concept had actually got developed long back, where treatment were tailored according to a person's prakriti. An aim of Ayurveda is to actually maintain health and healthy. So this healthy and disease actually in the shloka tells that it's a contextualization in the context of meaning. The personalization is in the context of individual. And we've been studying this, and we've been trying to find ways as to how we could kind of understand this concept, because we initiated our work in 2002 when we also kind of understood that there would be a gap in understanding the health, and maybe integration with these knowledge systems might actually be very useful for the current paradigm of precision medicine. There were fundamental differences. We realized that modern medicine and Ayurveda, both of them talk for all these things, but in modern medicine, if we have markers to assess predisposition, the therapy is actually, or the environment, lifestyle, there is no crosstalk between them. These are all measured or recommended in a very disconnected manner, whereas in Ayurveda, there is a concept of prakriti, and everything of lifestyle, environment, and diet is contextualized in the context of in a person's prakriti perspective, and as opposed to the treatment, which is mostly symptomatic, the medicine is customized. So we thought that if there are measures and objectivity today's date to measure it, and if there are principles existing, is there a way by which we could integrate them further? Because the purpose of both of them is to heal the people. So there is what Prakriti. So the interesting aspect about Prakriti is, I would say, it's a scale-free measure for assessing a human individuality. Because when Prakriti is assessed, it is not looking at one system, but it's looking at the anatomy, it's looking at the psychology, it's looking at the physiological attributes, it's looking at the physical functions in terms of body build, body frame, memory, anger, walking. All these aspects are looked at cumulatively in an individual, and this remains invariant. So even if we actually age, if we grow, the Prakriti is invariant after we are born, but then the pattern that we accumulate over our lifetime is actually based on what Prakriti we start off with. So as a result of it, in any population, Ayurveda describes that there would be 7 broad Prakriti types, and once they are able to assess the Prakriti type, then the health or the response or the disease trajectory or the individualized management can actually be kind of governed based on the individual Prakriti. So these are all shlokas from original Charak and Sushruta, just to show that it's not that we are placing modern knowledge onto an Ayurveda, but these are all Ayurveda descriptions depicted by a modern method. Now, what is this invariance about Prakriti? So, like Dr. Ram Manohar mentioned briefly, that's because there is a concept, there is a common organizing principle called Tridosha. Just like in the modern times, we think DNA is a common organizing principle with expression, RNA, protein, etc. According to Ayurveda, Tridosha is a governing principle, according to which a system will have a kinetic component, a metabolic component, and a structural component. And these all will be there in a system, but based on if a system has more of the kinetic component, then it gets defined as var, or sit or cuff, depending on what is the component. And this is Prakriti is described for everything, the environment, the person, and in a person, whatever is the most predominant of the dosha which is expressed, according to that, individuals are defined as Vat, Pit or Kaph, or intermediary between all these Vat, Pit, Kaph, and Vat. Now, these define the baseline of the individual. So, perturbation of this in an individual from their baseline is what is assessed for either a disease state or a perturbed state. So, for example, if there is of a Pit Prakriti, this much of a, if the Vat is of this kind, then for this individual it will be an unhealthy state. But for this individual, this is the health state. So so any perturbation, then you can realize, will actually be phenotypically differently manifested in these individuals. And the purpose of an medicine in Ayurveda is to understand the baseline and the perturbation from the baseline, to be able to give a drug which will get it back to a person's threshold and not everybody to a common threshold. So this also, or the same organizing principle actually feeds on to the translational component, which is called as a Sri Sutra. That's the connectivity between the causes to the phenotype to assess what is the appropriate recommendation. So Hetu, Ling, and Aushad is what is the translation, and all of this is ascertained on the basis of dosha. So that's why the dosha is pervasive across our head, and understanding the dosha gives a basis of understanding this network medicine context, which is actually coming up in big time in today's day. So there are functional attributes. What would so these are not like we talk about it in an abstract manner. There are clear-cut descriptions given as to what are the functions of Vata, and these are all Sanskrit shlokas. We have papers in which we've given them in much more detail. So manifestation of shape, cell division, signaling, anything which moves and governs movement is given the function of Vata. Anything which governs metabolism, heat component, immune surveillance component, that is governed by this, and things which give robustness to a system or fluid stability to a system or building up to a system is governed by Kapha. So now you can understand this kind of an understanding will take systems have these things aberrant, and you will know what is disturbed or what is the homeostatic state. Then what, how, as people are talking about GIS map of an individual, Ayurveda had those restrictions. We have reviewed, and Bhavna is actually key to kind of getting these across to us. And so Ayurveda talks about Shukra Shoni Sanyoge, that's the genetic component, Kal Garbhashay, Mathurahar Viha, that's the prenatal environment, mother's season of conception, what ahar vihar she had, and it is contextualized by jati, kul, desh, kal, vay, and prasatmanyata. So if you look at an individual, then you have to contextualize it with respect to all before ascribing a particular prakriti to a person. So that's the interesting part, that a prakriti of an individual is impacted by this, and once you have this form, then it governs what is the response likely to be. So, for example, so we have made from the conceptual, we tried to make depict it in a way by which we could actually develop working hypothesis to test it scientifically. So, for example, different age, Vata, Pitta, and Kapha are more predominant in the system. So, individuals can start out as one prakriti, but at the age to 30 years, Kapha is more in the system. So, what would happen is some individuals will have more overtness of system features of Kapha, and Kapha-related problems might be more impacting these prakriti individuals at this age. Whereas Pitta is more in this age, so this prakriti individual might have more overtness of the symptoms, and Vata is at this age. So it's not that an individual will get only doshas of that particular axis, but depending on what time, what their inherent dosha is, the perturbation will be actually have to be phenotypically adjusted or understood to be able to have an appropriate therapy. Similarly, different seasons could govern elevation of different doshas. So in springtime, if cough increases in the system, then cough people will be more impacted, or monsoon vata will be impacted, or early winter fit will be, or the autumn season fit will be impacted. So these individuals might have problems, health problems, in what places will actually be governed by their baseline, and this is also of the time of the day. For example, 6 to 10 in the morning and 6 to 10 in the evening is the cough time, so more cough in the system, 10 to 2 more fit in the system, 2 to 6 more vata in the system. So as a result of it, if a person presents themselves with a particular perturbation, then the doctors can also use the temporal information to be able to assess what is the nature of perturbation to be able to give a recommendation. Similarly, all these are also differently enhanced in different systems. For example, we have one genetic makeup, but not all genes are expressed in all the tissues. Similarly, vascular and cuff, they might be in an individual, but even the seat of vascular and cuff are different in different tissues. So that gives a tissue individuality. And this is how the system is connected from dosha to phenotype. Because if you have a vata individual, then these kind of systems will have more overtness of phenotypes, which will be distinguishing characters of who is vata, who is pitta, or who is kapha. And also if there is a disease, then what is that filter. So that actually connects the doshas to a system level, and this becomes the basis of how Ayurveda looks at the entire system and is able to predict dosha, perturbation, and have different diseases described. So different diseases are also described for vata, pitta, and kapha, and these are all very, very illustrated. And having a knowledge of this, then Ayurveda has this concept of when you look at a disease, then you have to give an appropriate drug looking at the individual perspective. So you cannot actually give the same drug to the same person if the state of health of that person is different. So there is an enormous documentation, and now the question is, this conceptual framework is there, how do we actually build a language or an ontological link so that we are able to quote the system in its essence and not in just taking it forward without having an iterative way of looking into it to glean more knowledge. So this I give an example of Jhumpa Lahiri's book of In Other Words, where he mastered Italian, and her autobiography of mastering Italian actually is being translated by somebody else in English, but it reads as if Jhumpa Lahiri is written. That's because he had mastered Italian in such a way that one could actually think that the book is being written by him. That's the idea of our genomics, and this is the journey. Bhavna has been key to it because this kind of a knowledge to iteratively quote from Ayurveda requires deep knowledge, and that's how we have been developing this process. So how do we go about it? So if we say vata, pitta, and kapha are these kinds of aspects of a system, we ask the question that could we query this? Could we query this in a modern language to get a modern interpretation so that we are able to quote this information and kind of use it globally, make it globally applicable? So we started with that if we take individuals at the end of the spectrum, would they, and if we take their blood sample, would they have overt expression of genes which govern metabolism or storage or signaling, or would they have variability which will make them more predisposed to this? So this is what we got to do. We took individuals, we took them and first ascertained using the Indian genome variation data that they come from one genetic background. Otherwise, people would say that we took people from different genetic background and are saying they are vata, pitta, and kapha, and took their blood samples to look at expression, variations, etc., and then try to see whether we can actually synthesize the knowledge in the context of what Ayurveda sees. So this is what we embarked on, and so we took people from one ethnic background, classified them on the basis of Prakriti, took the predominant Prakriti and looked at their biochemical parameters, looked at their expression parameters. This is summarizing the whole information. We have a publication, but what we could see was that even within the normal range, Vata, Pitta and Kapha tend to have their own kind of boundaries. So we think that every one of us has to move here to say we are diseased, but we find that if Vata is within this boundary, then moving to this itself will be a disease for Vata, whereas it will not be for Pitta. So this is what we got, and then we could find that there were certain processes which differed or differentiated Vata, Pitta and Kapha at the molecular level. So that, for example, we got processes like cell cycle being very different, and this actually has a description in Ayurveda is what Bhavna could actually tell us. So this was our first paper. But moving ahead, then we said that if this is a difference, does this difference make sense? So I'm not going to get into the details. Nevertheless, we got a gene which is an oxygen sensor gene. It differed between Kapha and Pitta in such a manner that it predicted that Kapha individuals might not be doing so well in low oxygen conditions, whereas Pitta people might be doing better in low oxygen conditions. We found that this kind of a makeup was actually present or differently in people who reside at high altitude. So here the individuals are more like Pitta, and we then suggested that if that was so, could we have people of this kind of prakriti or this kind of a genetic makeup having more problems if they go to high altitude. So these were sea level dwellers, and we had a cohort who developed HAPE at high altitude, and we could actually see that whatever was described for Kapha was more in people who went to high altitude and were maladapted, so had a problem of HAPE. So this for the first time told us that even without exposure, Prakriti-based methods could help us identify people who might be differently adapted to high altitude conditions. And as a result of which, this was a very interesting observation. But then again, we went back to Ayurveda and we found that there are descriptions about how high altitude might not favor people who are of Kapha Prakriti because Kapha predominance is there in high altitude. And so diseases of Kapha will be more. So Pitta Prakriti individuals might be more adapted. This is what we could provide an example, and this has got validated in different world populations, which tells that the robustness of our data after 10 years also this has stood the test of time, and the variations which we discovered has been due to aerobic capacity. So that tells us that we could actually use Ayurveda method, identify a core axis which is important in many diseases. So if individuals differ with respect to this core axis, then there might be differences with respect to different kinds of diseases. As a result of which, if Ayurveda doctors are looking at Prakriti from this interface perspective, they might be able to cure a multitude of diseases using the same kind of medicine, or would be able to predict it. So using this, we've been able to show that how if you can actually modulate this, you can modulate asthma, and we could also show that how, because of modulating this, you could also have people who are different at risk of different diseases like stroke or thrombosis, and how these also the descriptions match to what we have in Ayurveda. So what I'm trying to just emphasize is that this is not just taking information, but also going iteratively to see whether people show differences. And we've been able to provide many such examples that how in hypoxia, who will get bleeding, who will get thrombosis, might be dependent on a person's Prakriti makeup. And as a result of this, these kind of information gets important in stroke. There also Ayurveda has descriptions beyond predicting risk. They have diet and lifestyle recommendations in particular habitat. If hypercoagulability is there, cloudy weather condition is there, what kind of things a person should have. So as a result of which, if you have a genetic makeup which makes you predisposed, you have a job which makes you settle in a particular place, then could you actually have recommendations which can keep your doshas in check so that you don't have a disease. So this is what we could kind of discover.
If you don't mind, this is just wonderful presentation of yours. We are very, very, very sorry, but if you may conclude within a few minutes, kindly. Very sorry.
Based on this, now we've been able to kind of, Bhavna has been able to show that how this knowledge can allow us to map drugs which could be relevant for amelioration of hypoxia condition like the COVID-19. And that's what we are doing now. We are replicating this in multiple populations of the world. We are doing machine learning to be able to kind of recapitulate Ayurveda constitutions by multidisciplinary approach. And at the end, we think that Ayurgenomics is not new. It's a old thing which is contemporary still. It can propel lots of discoveries. And finally, these are the people who are very keen to collaborations and support. We are supported by Ministry of Ayush for a sense of excellence, and would like to close here. Thank you. Sorry for
Thanks to Professor Mukherjee for her excellent talk, and really we understood that if we want to integrate some paradigm with other paradigm, we need to understand each paradigm nicely and then to get the interface between them and then to integrate. So nicely she has integrated or elaborated the interface between Ayurveda and genomics and how to integrate. So I would like to request Professor Shukla and Shruti, Madam, to run the question answer session.
Yeah, thank you very much, Dr. Mukherjee. It's a brilliant presentation and brilliant insight about the topic. I have just a very quick question, which may also reflect the audience that are live seeing in YouTube. So first is very quick. What are the empirical counterparts of Prakriti if we want to identify in terms of modern practices? So how you can discriminate between two different or three different Prakriti in terms of like very common, easy to understand for the people. And second is, are there any animal models for different Prakriti?
very good question. So the empiricals, we have a questionnaire which Bhavna has developed, and over 30,000 people we have administered it, and that is what is getting into this Ayushman Bharat initiative. And I very briefly showed that we have used machine learning methods to be able to show that there is a phenotypic structure which can be formalized by algorithms. But this actually relies on, so all the descriptions of Ayurveda have been converted into an objective questionnaire. We have a screening questionnaire and a very detailed questionnaire. Plus, he is also integrating measures of anthropometry, physiological, autonomic functions, skin measurements to be able to also derive what are the values which need to be contextualized by every population. So this has been a very parallel research for the last, how to objectively design questionnaires, then do the molecular analysis. So our study has started from there, and we've done it in Russia also, so we know that it works. And the other question was
animal models. Are there animal models for Prakriti?
Like I said that we are able to use animal models once we know the doshas and once we know what the phenotype is. Like in hypoxia, when we got to know it is hypoxia, we could develop an animal model of asthma where we could recapitulate hypoxia, and then we use the drugs which are used to treat the dosha in that animal model to explore doshas. So Ayurveda has descriptions about animals and comparative genomics. That's what I understand. We have not got into that as yet, but there would be descriptions, I would presume.
I slightly to on this topic very quickly. In animal models, can you discriminate between, like in animals, can you discriminate between these doshas, Prakriti?
So we can, if we know the molecular counterparts, then we can modulate them and we can see the phenotypic expression of the doshas. But if you say animals, are they Vata type, Pitta type, Kapha type, there are descriptions apparently about some features which are kind of compared with animals, as well as some of our collaborators, they said that when they look at different strains of mice, they think that whatever we give a description, certain strains seems to be more Vata-like, Pitta-like, but we've not tested it well.
Okay. Thank you very much. Brilliant presentation.
Thank you so much for your wonderful presentation, ma'am. Thank you.
So, Professor Chatterjee, you're not audible yet.
Yes. Thank you,
Yes.
Professor Mukherjee, for your excellent talk. We'll maintain our relation with your academic friendship. We'll extend, we'll forward it. And it is excellent work that you are performing in your center. It is the first center in India, the Center of Excellence on Hydrogenomics probably. So thank you, thank you. Thank you.
Namaskar.
Log off, right? I can log off.
Yes, yes.
So this is really brilliant. I mean, Professor Shomesh Kumar, Professor Jyotirmoy Chatterjee, thanks immensely to Professor Chatterjee for chairing this excellent pathfinding and forerunning session on Ayurveda, biological sciences, which is one of the key domains of India. And this was absolutely brilliant. You know, the two talks by Professor Ram Manoharji and by Madam Professor Mitali Mukherjee. They were absolutely brilliant. And I think we need to know so much. And as Professor Kumar was saying, to every modern validated slide, there was also a quotation from the Shrutis or from an ancient text. So that's really a synthesis, absolutely. So with this, we move on to technical session 6. Technical session 6, which is on Jyoti Tatha Mahajagatik Vidya, the positional and astronomical sciences. One of the greatest surprises that India's rishis, the Vedas, the Shrutis, our Upanishads, and particularly the Vedangas, the Shara Vedangas has provided to the whole world. And this session is going to be chaired by my friend, colleague, our friend, colleague, Professor Somnath Bharadwaj from the Department of Physics, and also one of the great contributors of great learning in this institute. Professor Somnath Bharadwaj needs no introduction, and he's also one of the persons who runs the study circle that runs under the ideals and philosophies and the works of Swami Vivekananda, which is called the Vivekananda Study Circle. And this session is going to be supported by two excellent scholar faculties, Dr. Vishwanath Shukla of the Department of Physics and Dr. Shivakiran B.N. Bhakta of the Department of Physics. So we'll have two excellent talks and perhaps another brilliant session, of course, from two speakers, Professors Mayank N. Bhatia from the Tata Institute of Fundamental Research, Mumbai, and from our former director, our patron, our guide, and our friend, philosopher in the times of need and directions for the Center of Excellence, which will be coming in the days to come, which is no one else but Professor Amitabh Ghosh of currently at IIT Shivpur, and he is a person who needs no introduction. So it's over to Professor Somnath Bharadwaj to take over the mandate of this session. Professor Bharadwaj, please. Thank you so much for coming in.
When you go to a Tirth, to some place like Kedarnath, the body and mind first go to Haridwar, Rishikesh, Devaprayag, Rudraprayag, Guptakashi, Gaurikund, Kedarnath. We are now, you may say, the astronomy mini Tirth, and I welcome you all to this session. The sun rises, the sun sets. These events mark the day. And the length of the day elongates slowly over a period of time, gradually. And then again it shortens. This period continues. And the moon, it waxes, it gets brighter, bigger, and then it wanes. Again, this period continues. Very recently, we had Durga Puja. We had the Shukla Paksh, that is the waxing of the moon, and it culminated in a Purnima, full moon, when we had Lakshmi Puja. And now we are in the Krishna Paksh, the waning phase of the moon, and this will culminate in Kali Puja, Diwali. So the point I wish to make is that astronomical events that occur in the sky, they deeply influence human life. We are intimately connected with things that happen on the sky, in the sky. And Indian astronomy, so the study of things that are happening in the sky, astral, on the sky, it dates back to prehistory, you may say. The earliest record, to the best of my knowledge, is in the Vedangas, which are earlier auxiliary text of the Vedas. So today we have two talks on this topic, the ancient Indian astronomy, and we have two very eminent speakers who will speak on this. The first speaker is Professor Mayank Wahiya. Professor Mayank Wahiya spent most of his academic career at the Tata Institute of Fundamental Research at Mumbai, and he joined there in 1979, and that is where he did his PhD, and most of his academic career was there. His interests primarily interests are in high energy astrophysics, that is cosmic ray, gamma ray, and X-ray astronomy. And he has been using these to study a variety of phenomena from the sun to the interstellar medium, gamma ray bursts, etc. And he has worked extensively in this field. And he was in between, he was also associated with various foreign universities in UK and the USA. He served as the director of the Nehru Planetarium in Mumbai for a brief period of around couple of years. And few years ago, he retired from the Tata Institute, and he is currently the Dean of the School of Mathematical Sciences at the Narsi Monji Institute for Management Studies. Another interest which Professor Wahiya has is in astroarchaeology, which is a relatively new subject and which is closely related to the topic that we are discussing today. So today Professor Wahiya is going to tell us about events so today he is going to tell us about landmark events in the evolution of astronomy in India. Professor Wahiya, please.
Thank you very much, sir. Thank you very much for that introduction. I am Mayank Wahiya, and I am going to talk to you about origin and growth of astronomy in India. And the previous speaker suggested that astronomy begins with Vedanga Jyotish. I will try and show that in fact it dates back to even earlier interesting ideas. So I hope you can see my slides. So what I'm going to do is to simply look at some landmark events in the growth of astronomy in India, and then look at how it compares with other aspects of the society. So the first question obviously is, who studies astronomy? Why would a culture be interested in astronomy? Because the reason why that would happen is because humans are interested, because it's a utilitarian science as well as it's a fascinating subject at night. If you don't have electricity, etc., to disturb your night, you can imagine how beautiful the night sky looks, and it could not but attract the attention of everybody. So artists use astronomy to show various aspects of the sun and the planets and the constellations and so on. Farmers obviously use it because they want to know when the monsoon will be, when should they sow the seeds and stuff like that. Travelers need it because it is useful for direction, especially if you are at sea, when there is no land marker to go by. They would often take the sky as the marker. Calendar makers obviously want to know, so that some of the earliest events were associated with phases of moon. We know that 12 full moons nearly makes a year, it makes 354 days. And then you had to, if you wanted to synchronize solar and lunar year, what you would do is every 2.5 years you would add an Adhik Mas and get back your solar and lunar calendar. And this is an idea that dates back to at least Vedanta Jyotish and probably earlier. Priests needed to define the exact time of any ceremony and so on, they would be interested. And astronomers, of course, would be interested in knowing what is going on in the sky. So it's a very versatile subject which a large number of people would be interested in and work on. Astronomy also affects us in many ways. I was introduced to the idea that this Purnima and Amavasya are going to give you the two festivals of Dasera and Diwali. But even hours, days, fortnights, months, a year, 5-year period, 19-year eclipse cycle, 60-year Jupiter and Saturn cycle, and hundreds of years of precession all come from astronomy. So clocks that we normally use are essentially originate in astronomy. But acquiring this knowledge of astronomy is non-trivial, and acquiring this knowledge of heavens requires an enormous amount of expenditure of time, resources, and intellect and technology. And what we will do is that we will look at how this evolution has happened, and we will also see how cultures require to mature to various level of sophistication in order to be able to understand something new that they see in the sky. Typically, astronomy begins like this. This is one of the oldest rock arts probably in Kashmir, and you can see this variants at a lot of other cultures also, especially in Australia and so on, where the idea is that the heaven has a superhuman called superhuman who controls the movement of the sun and the moon, and that superhuman eventually is the great one. And very early people realized that monsoons bring fertility to earth. So the idea of Mother Earth and Father Sky is as old as human beings, or even probably earlier. There are suspicions that even Neanderthals probably entertained such ideas of Mother Earth and Father Sky. And you can see them in rock arts. But rock art, in fact, has much more information hidden within it than simply beautiful representation of art. And to take an example, I will take this example of a rock that was found in Burzaham in Kashmir. It was dated to sometime before 2000 BC because it was used secondarily in a house that was dated to 2000 BC. And you would normally think that this is simply a hunting scene and there are two suns in the sky for whatever reason it is, and that is all that is. But the obvious question is, why would an artist draw two suns instead of one sun in the sky? One obvious explanation would be that it is the moon, but there is no way moon would be as bright as this when it is so close to the sun. And so we suggested the idea that maybe this is a record of a genuine astronomical event. And the question that we asked is that maybe it represents another bright object in the sky. And apart from comets, which are drawn differently, you would not expect anything other than an exploding star to be seen. So we know that exploding stars, since time immemorial, have created very bright images in the sky, and they can be brighter than the moon in the night sky, or even as bright as the sun in the night sky, and therefore they would create a deep impression. So we asked ourselves, if this is an astronomical event, what do you look for? So you look for an astronomical event that happened, or a supernova event that happened between 2000 BC and 10,000 BC. It should be close to the path of the sun or close to the ecliptic, and it should be noticeable in the daytime sky. And fortunately, because the supernova remain alive in X-rays for millennia, we have complete catalog of supernova remnants in our surrounding. And there was only one object, which is classified as HG9, which met the requirement that it was brighter than the moon in the night in the sky, and therefore it would be visible in the daytime. It was close to the ecliptic path of the sun, and it happened around 3000 BC. And when you look at it, then you go back and plot it in the sky, In fact, you get something even more profound, which is that the rest of the image, that the rest of the image of the stone that you see over here actually begins to make sense, because if you plot the supernova over here, Orion, Taurus, and the dog essentially come out beautifully compared with the other stars. So this, taking the supernova location as fixed, we get that this hunter is Orion, this bull is the Taurus, the bull, and you get other constellation matching. And this black line that you see is essentially the path of the sun. So you get the sun, you get the supernova remnant, which would have been brighter than the moon, and then the rest of the painting makes sense, because now it is no longer an arbitrary hunting scene. This is Orion, this is Taurus, and these are Andromeda and other constellations. So we think that the rock art in India is in fact far more profound than we would normally call it. It's not such a cultural, just a cultural expression. It is also a record of something spectacular that they have seen in the sky. Then there are megaliths, which is the next level of sophistication of a culture. So megaliths are large stone structures used for a variety of purposes. In Europe, we know things like Stonehenge have been shown to be astronomical in use. In India, they are found in all parts of the continent. More than 2,000 such structures have been catalogued in South India alone, which has the largest collection of megaliths. And there are all kinds of shapes and sizes that you get, from dolmens to house-like looking to stone alignments and so on. And we believe at least some of these were created for astronomical purposes, and I'll show you evidence of that. So there is a site called Baise near Udupi, near Mangalore, where you can see a whole bunch of collection of stones over here, and then there are some mounds, etc. And if you look at that region carefully, you would see that what you think is a random collection of stones, and you can see if you take a Google view of it, this is what the stone collection looks like. But and some of these stones are as much as 3 meters tall. So we are talking about extremely tall stones, apparently randomly aligned. And if you are not careful, you would simply record it as a randomly aligned collection of stones until you go back and put them into computer and ask what happens. When you do that, you get a very interesting feature. What I have here is the shadow of each of these stones in the sky as seen on winter solstice at Baise. And what you see is the shadows are fairly long, but the black colored line, the red colored lines are the cases where the shadow of one stone meets another stone. So somebody has set up a whole set of stones of various heights and so on, and then go and remember these stones are about 3 or 4 meters tall. So we are talking about really tall stones, and then gone ahead and marked the winter solstice day by putting another stone at the other end. And if you match the stones, a winter solstice sunrise and a summer solstice sunset would be symmetrical, and therefore you get this matching of shadows, which is way beyond what you would expect by random number. So somebody has created an observatory like that, where shadows of one stone goes and meets another stone only on specific days. So all you have to do, and there are multiple markers to make sure that there are no errors in this, and you could go there and see on any given day whether the shadow of one stone goes to the how far south of that image it is, or even north of the image it is, and you could determine the season of the day. You could determine the season, you could determine the arrival time of monsoon, you know when equinox will come and all that, because on other days the shadows will be on the south. So you can actually, so this random looking collection of stones is actually a megalithic observatory. And there are various kinds of observatory. There is another observatory at Nilaskal, which is another 20 kilometers away from Baise and so on. So many of these megaliths are actually astronomical observatories in their own way, and you need to understand them carefully. Then, of course, we come to Rigveda itself, which says, in Vedanga itself, it says that just like the comb of a peacock or the crest jewel of a serpent, so is Jyotisha, the stand on the heads of the auxiliaries of astronomy. And then you have Rigveda. Rigveda itself has two parts as far as astronomy is concerned. The first part is Vedang Jyotish, and this is largely discussion on calendrical purposes. How many days a year, 354 or 365? If you take civil days of 30, about unit length of 30 days, then you have 360 days. And then how do you correct for these 5 days? Or if you take full moon to full moon, you have 354 days. Then you have to have 11 blank days. And a settled culture cannot have blank days, so you go and add Adhik Mas and so on. But the second and more important part is the Samhita itself. And Tilak has done, the great Lokmanya Balagangadhar Tilak has done phenomenal work on studying the astronomical references in Rigveda Samhita. itself, and the book is called Orion. In that, he looks at this particular region of the sky. So this region of the sky has Orion, it has Taurus, and it has Pleiades. And this region has attracted the attention of astronomers for a long time because it is first of all very easy to see, and interestingly, the vernal equinox point itself moves. So this is the direction of movement of the vernal equinox. Because of the spin of the Earth changes with time, gradually the location of sunrise at vernal equinox changes with time. So in 7000 BC, the sun rose in Canis Major at the time of vernal equinox. In 6000 BC to 3000 BC, it rose in the Taurus region of the sky, and Orion and Taurus region of the sky. And in 2000 BC, it was in Pleiades, and today it is in Pisces. But Tewari clearly demonstrates to you that there are references in Rigveda which show that they remember rather vaguely that the dog star was associated with the vernal equinox. There is more firm evidence of vernal equinox with Orion and with Taurus, and they clearly talk about that day with the time of Rigveda when the vernal equinox is in Pleiades. And they actually talk about the pain when people realize that the vernal equinox is no longer in the constellation which they thought it was, and so on. And so clearly, even though Rigveda probably was written after 2000 BC, it carries memory of olden astronomical events, and including precession of the Earth and how various events occur. Tewari also, of course, claims with some justification that maybe the Rigveda people who came from the much farther north, where these constellations would have been circumpolar, and they would have therefore noticed these kind of movements much more easily than you can do from southern latitude. Then there is also tribal astronomy. Now, astronomy as we know it today, the common astronomy that is there comes out from Mesopotamia in 3000 BC. So they divide the sky, they decide the stars collections that make various constellations, and the entire world adopts that. So they are more or less similar. So Orion may have a different name in India, but so Orion may be called Mrugashirsa, the story may be different, but essentially the constellation division is standard. And the narration may change, the stories may change from region to region, but the constellation designs are more or less fixed. However, isolated tribes develop their own perspective of the sky, and they understand and interpret it in their own ways. And that makes a fascinating study because that is a really independent window to the universe. So we looked at astronomical traditions of about 10 tribes all the way from Nicobar to Western India and also in Central India. And that makes a fascinating study. And I'm going to give you one specific example. There is Canis Major or Ursa Major or Saptarshi, which represents this constellation as we are concerned, which are the Saptarshi, and we call it Canis Major. To Gonds and to many communities in Central India, these are in fact two different constellations. The first constellation is an old lady's cot with very precious, with the legs made with very precious metal, and the three thieves trying to steal her material. And the story is that this lady is not allowed to sleep because if she sleeps, then the thieves will steal the bed. And that tells you that this constellation is not allowed to set, and it must remain in the sky every night. And when you do that, you realize that the last time this happened in the region where the Gonds are settled was in 1000 BC. Till 1000 BC, this constellation never set in the night sky in Central India. Today it sets. Since 1000 BC, it has been setting. But clearly this shows that the memory of this story goes back to 1000 BC, 1000 BC or 3000 years ago actually, when this constellation never set because this lady was not allowed to sleep. So there are fascinating internal stories which can be mapped to history and so on. Another interesting example is that Pleiades, for example, is a very famous constellation. We call it Seven Sisters or whatever you want it. It's a open cluster of stars which you can very clearly see. But to Banjaras, who are essentially traders, this looks like a piece of jewelry. To the Kolams, it looks like, who are essentially foragers, it looks like a flock of birds just flying in the sky. To Korku, who are essentially meat-eating people and dependent on animal husbandry, this looks like a minced meat which the gods have prepared for themselves. To the Gonds, the same region looks like a threatening collection of, Taurus is a set of birds which are trying to eat up their harvest. So Pleiades is a bunch of stones that are thrown at the birds to shoo them away and prevent them from eating the harvest. which the gods are creating in Orion region, and the birds are in Taurus. To Varli, this is an oil lamp or a drum playing at a wedding. And to them, this Taurus and Orion region actually makes a whole festivity of marriage, but I obviously don't have time to go into it. In Nicobar, this is seen either as the king looking up down from the top to look after the people, or a bunch of elders looking at the village and giving it their blessings so that the village may thrive and do well. To Parthi, it is two jungle babbers. I don't know why that image has not come. Two jungle babber birds who are just flying in the sky, because Parthis have a very casual connection to sky. And in classical Indian mythology, like I said, these are the 6 ladies, the 6 wives of the Saptarshi who left them for various regions and separated out from there. So that's why we have 6 ladies here. The 7th one stays with the Rishi himself. So the bottom line is that astronomical beliefs of tribals are also very interesting. They are divided into various categories. They refer to sun, day and timekeeper. They know Venus and so on. They use it for calendrical purposes to decide when the seasons will be and so on. They use it as an expression of human activities, where Orion is a farming scene. They use it for mythological purposes, where comets are big brooms sent by God. Milky Way, which is a path of the dead or path of the animals. Shooting stars, which are the excreta of gods or traveling gods and so on. Cosmological, they have idea of Ursa Major or Canis Major, which is supposed to be this lady who does not sleep and so on. And then there are esoteric beliefs of eclipses, shooting stars, etc. in various other communities. I don't have time again to go into it, so I will not go into the details. But it's an interesting thing that annual repetition of these scenes means astronomical stories are carried much better over long time periods than any other stories, because other stories change. Astronomical stories come, the same constellation is seen every year, and therefore and for several months, and therefore the stories remain preserved much better. Different belief systems reflect the geometry. You can analyze this data from tribes, and it turns out that their relation to astronomy is their relation to the land. Depending on what they do, how they handle the land, is how they handle the sky. The human relation to astronomy is actually connected with the human relation to the land on which they stay. Then, Harappan civilization was an extremely sophisticated civilization. It is not possible that they did not have calendrical and astronomical observatories. And we think we have seen an astronomical observatory in Dholavira, which is one of the towns of Harappan civilization. So during Harappan time, the Dholavira is in the run of Kutch. We know that during Harappan time, the run of Kutch was actually filled with water. That is how we have white sands from residual salt. And we know that Dholavira was a big port for export of material from the Harappan civilization to the Western Asia. It so happened that Dholavira lies exactly on the Tropic of Cancer. And if you look at the layout of Dholavira, which is famous for a variety of reasons, there are upper town, lower town, stadium, and so on. But in particular, there is a bailey which is interesting. It is inclined in such a way that it is exactly latitude of Dholavira. In other words, if you were to stand at the bottom, at the top, you would see the pole of the sky around which all the stars move. There is an interesting structure there. For Harappans who are extremely precise in their architecture, it is unlikely that they would make a mistake and make a circle which does not meet on itself. If you look at an architectural drawing of it, it looks like this. And this is a strange object until you realize that it points exactly to the north and to the pole of the rotation of the sky. And there's another structure over here which we believe is identical to that this time facing exactly east-west, but we think these two are observatories for calendrical purposes. And all that you have, because this is on Tropic of Cancer, if you took this and made it into a hut, which is a small slit at 2-meter height, you would see that over the period of 1 year, the shadow, the noon sun would move from bottom to top and back again over a period of 1 year. So just with a log of wood properly marked, you could tell which day of the year it is with as much precision as you wanted, just by putting a log of wood and marking it out on this little hut with a hole in the top or in the ceiling of the hut. So we think this is an observatory that they use, and that Bailey is actually an astronomical observatory. Then there are punchmark coins that come up in India in 700 BC or so, especially in the Gangetic age. These coins are small, and each king minted his own coins, and each king put his own punch marks to identify that these coins belong to his kingdom, and then there are bankers marked and stuff like that. But typically these coins are 2 centimeters in size, consisting of either precious or semi-precious materials. But if you look at them, many of these punch mark coins typically have, even within their few millimeter size punch marks, you have these strange events of things shown on the shoulder of an animal, and you have other objects which are very interesting. And the most interesting to us are objects like these, where you have this circle or a moon's-like sign with 5 or 6 or 7 dots. And we think that is Pleiades. And if you think about it a little, it's interesting that the moon Pleiades conjunction is something that happens every 18.5 years and typically lasts a day or two. So this would be an important event for any astronomer to note that yes, this is the time we are entering of time when moon and Pleiades are now going to meet each other, Kritika essentially. And therefore these events we think are marked out on these punch mark coins, typically in sizes of few millimeter, where you note the conjunction of moon and Pleiades. Then there is Upanishads itself, which is full of interesting cosmogonical ideas. So you have in Vrihadaranyaka Upanishad, you have Yajnavalkya saying that the whole universe, earth in which we live is surrounded by water. The water itself is surrounded by air. So all this is in response to Gargi's continuing questions. Then Gargi asks, what is the water in? They said, water is in air, air is in sky. Sky is wrapped in the world of Gandharvas. The world of Gandharvas is wrapped in the world of Aditya, the sun. The world of sun is wrapped in the world of moon, and the world of the moon is wrapped in the world of nakshatras and devas, and then eventually devas, Indra, Prajapati, and Brahman. And when Gargi asks what about the world of Brahman, Yajnavalkya of course loses his temper and says that Brahman is the ultimate singular, and therefore there is nothing beyond the world of Brahman. But you have an interesting set of cosmogonical ideas, and except for the sequencing of some of the astronomical objects, like moon should have probably go immediately up below sky, then you get a fairly good understanding. Then there are interesting calendars in these things. So you can look at Big Dipper that we looked at earlier, which is Saptarshi. What Mahabharata says is that Saptarshi visits different nakshatras at different times, and that calendar can be defined. And you think that is obviously absurd because Saptarshi does not visit different locations. Saptarshi is fixed in the sky and nakshatras are fixed in the sky. But it turns out that Matsya Purana actually defines it in detail, and it says that if you take the first 2 stars of Saptarshi and take it to the axis along which the sky moves, and you connect this vector, you essentially take the point around which the sky moves, you take the first 2 points of Saptarshi, and whichever nakshatra it points to is the nakshatra of Saptarshi. And in 2000 BC, it pointed to Pushya. And Mahabharata says that Parikshit takes over the kingdom of Kurukshetra when the Saptarshi calendar is in Magha. And it so happens that this vector actually obviously moves because of precession. And to the extent that it was in Magha in 1200 BC, it was in Pushya in 2000 BC, today it is in Purva Falguni. So this vector actually moves, and there was a time around Magha when it actually moved 100 years per constellation. Then because of the way precession works, it stopped. The next constellation takes some 600-700 years. So they give up the idea. But the idea of Saptarshi calendar as mentioned in Mahabharata actually makes a lot of sense. And it actually allows you to date Mahabharata, which is consistent with other evidences, about the dating of Mahabharata. It comes to about 1200 BC. So various documents. So Rigveda, for example, like I just told you, has evidence records from 6000 BC to 2000 BC. Ruhat Samhita has a memory of what is called Rohini Shakat Ved, which we showed happened last in 5200 BC. Yajurved has says that vernal equinoxes in Kritika, which gives you 2350 BC. Yajurved Vedang Jyoti says that the summer solstice is in Ashlesha, which gives you 1370 BC. Lagada says that the polar latitude of Sravishta is given, which is 1340 BC. Mahabharata, I just told you, 1200 BC. And Parashara Samhita, which gives you description of seasons and constellations associated, and that gives you between 1100 and 1300 BC. You can actually date major events. Then if you are a fisherman, then you need constellations of your own right. And so what fishermen today have, or even till 13th century, this is a 15th century map. But even today, if you go to a fisherman in Mumbai and say you want to be smuggled to West Asia, they can't use modern technology. They use sky charts like this. According to this sky chart, for example, you should go along Kritika for 3 days or 4 days or whatever your ship speed is, and then go over to Bohi for 3 more days, and you would reach wherever you want to reach in West Asia. So they still use, or they could use these charts, which were essentially astronomical, so that you could remain in open seas and still find your way by measuring the speed and correcting for the constellations and so on. Then comes the period of Siddhantic astronomy. 500 AD, Aryabhatta does a phenomenal job in writing down the astronomical knowledge and mathematical knowledge that was known at that time. Its preoccupation is calendrical and planetary orbits, and it developed algorithms for various solving mathematical equations. It comes up with concepts of trigonometry, sine functions, and so on. Temples in India arise around 500 BC. And they're originally sepulchral. The idea comes from sepulchral memorial of Buddha. When he dies, everybody wants some part of him. So his hair are cut and spread it all over the place. But the first structures of religious purpose are essentially sepulchral monuments in memory of Buddha. Then people realize that it's a good place to collect people and keep your flock together. So Hinduism also adopts to temples. And these temples are not randomly done. These temples have very precisely done architecture and layout, which starts with a gnomon because you have to design the directions. But even within the Garbhagriha of the temple, for example, the Brahma sits in the center, but then Rudra, for example, must sit in northeast, northwest, Upper must sit in northeast, followed by Agni on one side, and so on. So this layout of the temple Garbhagriha is also precisely defined with astronomy and mythology in mind. Then there is mathematical formulation. At this stage, of course, people realize the mathematics can give you planetary motions and so on. It gives you importance of sine functions and others. Eclipses are calculated and movement of the sun is calculated. Planetary locations and astral charts can be made at that time. And that brings me to the astronomy of today, which is simply a continuation of older traditions with the addition of telescopes and other instrumentation, as well as realization that there are more wavelengths than simply optical waves. And advances in physics and other fields help you picture it better, but it's continuation of the same tradition. And satellite, of course, is the quality. Yeah, I'll just finish in 2 minutes. Together, therefore, they produce a picture of the cosmos. Now, you can do something more than simply collect them as stories. So what I have here is various tribes, the years since they have settled, and you can quantify their astronomical knowledge. And when you do that, you can cumulatively give credit to each community's astronomical knowledge. And when you plot this, the settlement period the settlement period against the sophistication of their astronomy, it turns out that you get a pretty good straight line, starting with tribal astronomy all the way to the most modern urban astronomy of 15th, 16th century. This is pre-satellite astronomy. But you can see that this knowledge actually increases. The more settled you are, the more astronomy you will know. So the bottom line is that astronomy impacts a wide variety of human activity. The annual repetition of astronomical myths means they tend to be remembered better, and they can give us insight into the past. They can even give you a map of intellectual growth of a civilization and its interaction with other civilizations, and it can provide timeline for various literature. Thank you very much. Yes, I have completed. Hello.
I think we will have the talks after the second talk. After I
Sure.
have the questions after the second talk. So
I will wait.
Yeah.
Professor Vahia, thank you very much for the excellent talk. We will have a few questions at the end of both the talks. It is superfluous for me to introduce the next speaker, but I think it is a formality that we have to go through. Professor Amitavo Ghosh is no stranger to us. Professor Amitavo Ghosh is a mechanical engineer, and much of his academic career was at IIT Kanpur, where he was a very distinguished teacher as well as researcher, and he has been awarded there for his teaching and he's an excellent teacher, and as you will for yourself discover shortly when you hear his talk that how good a speaker he is. Okay. He was the director of IIT Kharagpur from 1997 to 2002, and there were many changes in IIT during that period. After this, he went back to IIT Kanpur, and after retirement, he was at the IIEST, which earlier was the Bengal Engineering College, Shibpur, his alma mater. He taught there for several years. He is currently an honorary scientist of the Indian National Science Academy, Delhi, as well as the Indian National Academy of Science, Allahabad. Professor Amitabh Ghosh is a mechanical engineer, but you may say that he has a very keen interest. You may even say that he has a kind of affair with science and astronomy in particular, which he has been pursuing over maybe a couple of decades. And he has done a considerable amount of work on the history of astronomy in India, and he also has a book on this topic which was published by the Ramakrishna Mission Institute of Culture. It's a part of a series of books on the history of science in India. I invite Professor Ghosh to give his talk on the talk is on the antiquity and originality of astronomy in India. Professor Ghosh.
Thank you very much, Somnath. Am I audible? Can you hear me?
Yes, sir.
Hello.
Sir, namaskar. You are audible. You are audible. You are audible, sir.
Okay.
Okay, sir.
Thank you. Thank you very much. And a very good day to all of you and also the participants. I have been allocated 25 minutes and I will take up this short period to have a brief discussion on two aspects of ancient Indian astronomy. One is how old it is, antiquity, and also the amount or degree of originality of our ancient Indian astronomy. Both are to some extent controversial items and topics, as it happens with most of the things of ancient India. So therefore, I will try to present a very concise view what is found scientifically acceptable antiquity and the degree of originality of our astronomy. So now I think I will present the talk with the help of slides, and let me know whether you can see the slides. Can you see the slides?
Yeah.
Hello?
Yes, sir, we can see the slides.
Good. Thank you very much. I think as Professor Bharadwaj has mentioned, the topic is antiquity and originality of ancient Indian astronomy. And I think at the very beginning, what we have to decide that at what time we should consider astronomy in its beginning. As already mentioned in the previous talk, that the astronomical observation started from the, I'll say, the Stone Age period, and there are many megalithic sites, even in India, in South India, in Jharkhand, Northeast India, and many other places. So the important point is to clarify that, that at what time we should consider astronomy as a subject, the way we look at it. Now it is true that it is based upon observation, but it gets the status of science only when the subject becomes a combination of observation and mathematical calculations. In my personal opinion, then only we should consider that astronomy has entered its scientific era. The simple observation of the sky started from the Stone Age, as evidenced by the existence of various megalithic structures like Stonehenge. In India, as mentioned by Professor Bhaiya, and as you all know, that we also have a very large number of megalithic sites. Many of them are actually with astronomical significance. Now, I think the motion of the sun, moon, and planets were not a part of the observational program with these structures in general, and thus this presentation, astronomy, is considered as a science only after the observer started studying the motions of the heavenly objects using mathematical calculations. Now, the basic structure of Indian astronomy, we can divide it into following eras actually. One is pre-Siddhantic period, which you can date before 1200 BCE, early Siddhantic period 100 BCE to 400 CE, Siddhantic period from 400 CE to 1100 CE, late Siddhantic period from 1100 to 1800 CE, and the modern period, which is telescopic astronomy, which came to India through the European scholars and Jesuit priests. Now, the rediscovery of ancient Indian astronomy, we should have a very brief discussion on that. The credit of, because we had the astronomy, but as it happens with many other things, Indian scholars never really bothered about the past and the history of the things, and the credit has to be given to the European scholars. Around 1687, a few Jesuit scholars went to Siam. Actually, they were invited by their king, but due to a palace coup, they had to leave quickly, and they came to Pondicherry. Now, I think when they came, they had a fragment of a manuscript with them, and this contained rules for calculating the positions of the sun and the moon, and the positions or the, sorry, I have to remove this. The positions of the sun and the moon were calculated with the help of this table, and the principles on which these rules were framed were completely unknown and forgotten. And the astronomer Cassini, he analyzed this incomplete document and showed that it was necessary to subtract 3 minutes from the position of the sun and 40 minutes for the position of the moon from their calculated positions using these tables. Thus, Cassini showed that the reference meridian of the tables was 18 degrees west of Siam, that is Varanasi. You can see this is Siam, Thailand, and if you come 18 degrees to west, it matches approximately with the meridian of Varanasi. And so it was decided that these tables were prepared in ancient India and somehow made their way to Siam. So of course, later some more elaborate tables were discovered in Karnataka, but the major impetus came from Gentile, who visited Pondicherry to observe a transit of Venus. He was amazed by the speed and accuracy with which the Indian Pandits could predict eclipse without understanding rules. After his return to Europe and getting to know about Gentile's experience, a considerable amount of interest on ancient India's astronomical knowledge was created in Europe. The famous astronomer Bailey studied the tables, and after extensive analysis, he announced the period of preparation of the tables as 3102 BCE. This was accepted by both Laplace and Playfair. Now I will have a brief discussion on antiquity, how old we can consider ancient Indian astronomy. Now, as mentioned before, in Indian astronomy, the earliest system that was developed was the nakshatra-based pre-Siddhantic astronomy. It is easy to realize that although finding the position of the sun in the background of the fixed stars was very difficult, rather impossible, and there was no problem of locating the position of the moon, it also became very clear to the earliest astronomers that the moon changes its position and returns to the original position after about 27.5 days. So this position of the moon was marked by a group of fixed stars, and these stars or these markers in the sky were called nakshatras. Thus these 27 nakshatras were given the names, and the pre-Siddhantic astronomy was based upon these 27 nakshatras. Since the moon and the planets all lie in the plane of the planets, that is the equatorial plane of the sun, or we call it the plane of the ecliptic, when observed from the earth, all planets, the moon and the sun always move along a path which is very near to the ecliptic. Sun moves exactly on the ecliptic, but the others are very near to it. I will not go into the discussion of this. This is our Milky Way galaxy, and this is the plane of the Milky Way galaxy. Our sun is about 27,000 light years from the center of the galaxy. This plane, which is inclined to the mid-plane of the galaxy at 60.2 degrees, is the ecliptic plane where all the planets orbit, etc. Now, when you look outwardly from this, there are 27 directions pointed to the 27 nakshatras, this is Jyeshtha, this is Vishakha, and this is Mrigashira, Ashwini. I have shown only a few, not the 27 ones. This is the general configuration, but for a more detailed thing, we can see this figure and the 27 nakshatras with their names are here. I will not go into the details of the names. It is all known. And this is the table along with the primary stars of the constellations or this group of stars called nakshatras. And this was the primary foundation on which ancient Indian pre-Siddhantic astronomy was based. Now it was also noticed that the full moon at this position, and when it comes back to the same position after 27.5 days, I think the Earth has already moved because that is also orbiting the sun. So therefore the next full moon will be somewhere here, which is about approximately 29.5 days. So this is called this synodic month, and the positional period is called the sidereal month. So therefore it was seen that the full moon at a particular nakshatra, say for example Vishakha, then the month around this, that means when the month was completed, is called Vaishakh. In the next month, the full moon was at Jyeshtha, so the name of the month will be Jyeshtha. This point is important at a later time, that's what I am explaining this. So that's how the 12 names of the 12 months, which are nakshatra based and which came to India first in the pre-Siddhantic astronomy. Its significance will be explained when we discuss the originality of ancient Indian astronomy as discussed by Max Muller. Thus the earliest calendar was a nakshatra based lunar calendar. The names of the months used to be based on the position of the full moon among the nakshatras. One lunar month used to be from one full moon to the next full moon. Masa was the old word for moon. That's why it was called Purna Masa, from which we have got Purnima. Later, of course, Masa also became the word for month, but it was not the original word. Later, of course, in Puranic period, the month was from the new moon to next new moon, and the name used to be on the basis of the nakshatra where the full moon took place during that period. Now, the antiquity of Indian astronomy, if you have to understand, we have to use the astronomical descriptions contained in the ancient scriptures of India. Now, I think although the lunar calendar was easy to compile, soon the ancient observers in India realized that the seasons are linked with the solar cycle. Thus, they had the wisdom of developing a lunisolar calendar. A solar year was a little more than 12 lunar months, and some adjustment procedure was also developed to correct the mismatch after some years. In the earliest times, the Rig-Vedic era, only 3 seasons were identified. And among the planets, only Jupiter and Venus were identified. Later, gradually the system of dividing a solar year into 6 seasons and 12 months was developed. And in the later Rig-Vedic period, the year was already divided into 12 months and 6 seasons. Although the names of the months were not the nakshatra-based names, as you can see, these are the seasons in the Rig-Vedic period, and the names of the months, each season had 2 months, like Basanta had Madhu and Madhava, Grishma had Shukra and Suchi, like that. Now it is not easy to find out exactly when the nakshatra-based system was started. The last book of pre-Siddhantic astronomy in ancient India that has survived is the Vedanga Jyotish, as you all know. Although the name suggests this book to be a religious text, but the book contains shlokas which are nothing but algorithms for calculating the mean positions of the sun, the moon, to determine the tithi, that is a lunar day, but it got preserved as a part of the Vedas, fortunately. And the text contains information about the stellar alignments when the text was composed. Because of the precision of the equinox, the star alignment slowly changes, The equinoctial points shift approximately 1 degree every 72 years. And this principle of archaeoastronomy can be used to determine the antiquity of Vedanga Jyotish. Now, Vedanga Jyotish is available in two recensions. One is Rik Jyotish, other is Jojur Jyotish. In total, there are 49 original slokas, and it was not easy to decipher these texts, but later, with the help of many European scholars and Indian scholars, all the slokas have been now been deciphered. So, verses 6, 7 and 8 of Jojur Jyotish describes that at the time of composing the text, the stellar alignments were as follows. The winter solstice was at the start of Nakshatra Dhanishta. The summer solstice was at the midpoint of Nakshatra Aslesha. Comparing this with the current situation and the known rate of precision, the date of the above observation is around 1400 BCE, which is the currently accepted date of Vedanga Jyotish. However, the earliest astronomical reference in Rig Veda, Sloka Book 5, 77, 1 and 2 Sloka, states that Ashwini Nakshatra used to rise heliacally, that means just before the sunrise, during the winter solstice period. The main star of Ashwini Nakshatra is Alpha Arietis. Its heliacal rising in winter solstice could be possible around 8300 BCE. It is a very high degree of antiquity. Of course, there are many other references to astronomical events and alignments which takes us back to almost 4600 BCE. So therefore, without going to the details, we find that if you study all the Vedic and other texts, that the astronomically important descriptions, there are many, but only few are shown here. Though it starts at 8326 BCE, later you get other dates approximately in the 5th millennium BC to 4th millennium BC, and Mahabharata war has been dated by various scholars, but nowadays it is around 14 to 1500 BC is considered to be approximately the date of Mahabharata war. So therefore we can say that when these descriptions of astronomical alignments etc. were there, nakshatra system was developed, so it can go back to 5th millennium BC approximately. Now we will now discuss the next point is originality of Indian astronomy. How original was our Indian astronomy and how much we borrowed? Now, so far as the question of originality is concerned, the topic can be divided into two parts. One is originality of the pre-Siddhantic astronomy of India and the extent of originality in Indian version of Siddhantic astronomy. Because by that time, we already had a lot of interchange with or exchange with the Hellenistic astronomy, as you all know. The primary foundation of the pre-Siddhantic astronomy is the nakshatra system. Is it originally Indian or not? Since in Arabic astronomy and in Chinese astronomy also, a concept similar to Indian nakshatra system exists. In the Arabic system, the nakshatra system is called Manzil al-Qamar, meaning that stations of the moon. And in the Chinese system, the lunar asterisms are called Xiu. The debate arose about the question which one is the original among the three. Although quite a few European pundits thought that Indians got their astronomical knowledge from the Arabs, the contention did not last long. The Arabs themselves accepted that they received the science of astronomy from India and Greece, and this point I will again briefly mention later. But quite a few European scholars, primarily led by M. Bio, were of the opinion that the lunar asterism system was first developed in China and then came to India via Arabia and Iran. Bio's proof of non-originality of the ancient India's nakshatra system rested predominantly on his personal opinion that ancient Indians were incapable of accurate and prolonged astronomical observation. There was no other scientific evidence of his decision. But the scholars who were intimately familiar with the ancient Indian astronomy did not accept the view proposed by Bio that Indians got the nakshatra system from the Chinese Xiu system of 28 star groups around 1100 BC. And the scholars were divided into two groups. But the strongest proof that the Chinese system was derived from the India's nakshatra system was forwarded by Max Muller, and that was based on purely linguistic evidence. In brief, I am just mentioning it as follows. Max Muller proved that the three names of the winter months in China, Pewa, Moko, and Folkuna, are derived from the Indian winter month names Pausha, Magha, and Falguna. But the Indian month names were linked with the full moon positions among the nakshatras just I mentioned. And such a linking of the nakshatras with month names does not exist in any other ancient astronomy. Based on this logic and of course few other points mentioned, Max Muller concluded that the nakshatra system was originally developed in India. In pre-Siddhantic astronomy, the calculations used to be for the mean positions of the sun and the moon primarily. It is not clear exactly when Siddhantic astronomy started being practiced in India, but by the 5th century CE, its practice became quite established. But in some older versions of Surya Siddhanta, which was the main text, the concept of Sigrocha and Mandocha played important roles for taking care of the uneven motions of the sun, the moon, and the planets. You all know that these uneven motions were noticed by European and Greek astronomers, and they developed the epicycle difference system. But these uneven motions were explained by another theory in the transition period between pre-Siddhantic and Siddhantic astronomy in India, that it's a Prabaha theory, implying the god controlling the motions sitting at the apogee through cords of air, which was called Prabaha. But ancient astronomers of India were far more thorough than their Greek counterparts in dealing with the uneven motions, which was explained not using the concept of epicycles to begin with, and classified the planetary motions into 8 classes of uneven motions as follows: Vakra, Anuvakra, Kutila, Manda, Mandalara, Sama, Atisigra, and Sigra. This is considered to be a relic of some forgotten part of ancient astronomy in India. Even in the Mahabharata time, 5 planets, the sun and the moon, were studied, and the zodiac was divided into 12 parts representing the sun's positions each month, but no names were given. Though in some ancient texts the word Mesha is found, but not much evidence was there that astronomy followed a purely zodiacal sign-based system. The other model of Siddhantic astronomy, following the different epicycle system, which was very similar to the method followed by the Greek astronomers developed by Ptolemy. Astronomer Colebrook studied both the systems and announced that though the systems have similarity, under no consideration can it be said that the Indians copied from the Greeks. Greek system was that this is the center of the system, not exactly the sun, slightly away, or the earth, not slightly away, and this is the circle called the deferent, and a heavenly object, a planet or moon or something. So that moved in another circle, which is called epicycle, whose center moved along another cycle, which is the deferent. And so the path of this used to be something like this, which could explain the uneven motion and also the retrograde motions. Colebrook also found that the parameters in the Indian system were very different from those in the Greek system. I am not presenting the tables that showing the difference between the major parameters, but in most cases, the Indian values were more accurate. Furthermore, the epicycles in the Indian system were not exactly circle, but were of oval shape, perhaps elliptic. Unlike those in the Greek system also, which were circular, in some cases the epicycles in Indian system were made to vary in size with time. That means the radius or the size of the epicycles were not constant. That was varying. So that way the much finer division of the unevenness of the motions could be explained in Indian astronomy. So therefore astronomer Burgess, who translated Surya Siddhanta, opined that there is no question of Indians copying the Greek system, only hints could have passed from one people to another, and that too at an early period. Indian system used parameters which are decidedly more accurate than their Greek counterpart, and he said, quote, "I should be disposed to conclude that the Indians were in this instance, teachers rather than learners. Here a brief discussion of the relation between the Indian astronomy and astronomy in West Asia is very relevant, as I mentioned earlier. It is interesting to note that the first major impact on West Asian astronomy was made by the early Siddhantic astronomy through the translation of Sanskrit text into Arabic. S.A.H. Rizvi, a mathematician specialized in the history of astronomy, has the following to state. The foundation of Islamic astronomy started during the reign of Abbasi Khalifa al-Mansur, 8th century CE. This happened after the Siddhantic texts were translated into Arabic. A copy of the Brahmagupta's Brahmasputa Siddhanta was brought to Baghdad from Sindh in 770 CE, and Yaqub ibn Tariq and Ibrahim Fazari translated it as Sin-Hind. Later, the Aryabhatta of Aryabhatta I was translated as Arjbad by Abdul Hasan Awazi. Another classic of Siddhantic astronomy, Khandakhaddaka of Brahmagupta, was translated into Arabic as Arkand by Yaqub ibn Tariq. These three important classics remained the basis of astronomical computations for astronomers who used Arabic medium. According to Said Suleiman Nadavi, although Ptolemy's Megale syntaxis was translated into Arabic as Al-Majesty, which later in English has become Al-Majest, but it was actually Al-Majesty. For a long time, the Arabic astronomers from Baghdad to Spain, because Spain was under Arab control for 700 years, they clung to Sin-Hind, which was originally from India. The following excerpt from S.B. Dixit's book. He was one of the very important scholars who studied ancient Indian astronomy and published his book in Marathi. Now it is available in English. Towards the end of the 19th century, can also throw light on the antiquity and originality of the Indian system. He says, I quote, "The oldest extant record of observation is that of an eclipse observed by the Chaldeans in 720 BCE, and that of the Greeks about the winter solstice observed by Mithun in 430 BCE, but we had already been observing the solstices as far back as 1400 BCE. So both the originality and the antiquity are hinted in these findings. Finally, I would like to conclude this talk with a passage from Playfair's paper published in Transactions of the Royal Society of Edinburgh about 2 centuries ago. I quote, "Of such high antiquity, therefore, must we suppose the origin of this astronomy, unless we can believe that all the coincidences which have been enumerated are but the effects of chance, or what indeed were still more wonderful, that some ages ago there had arisen a Newton among the Brahmins to discover that universal principle which connects not only the most distant regions of space, but the most remote periods of duration, and a De Lagrange to trace through the immensity of both its most subtle and complicated operations." Thank you very much. I have finished, Professor Bhattacharya.
Yes, thank you very much. So I take this opportunity to thank Professor Vahia and Professor Ghosh for their excellent talk. My colleagues, Professor Shiv Kiran Bhakta and Professor Vishwanath Shukla will now conduct the question answer session. We have had several questions coming in over the internet, so they will present these questions to you. Please take over.
Okay.
Thank you, Professor Bharadwaj. Thank you, Professor Vahia and Professor Ghosh for the very interesting talk on Indian astronomy. We'll just ask a few questions. We have several of them. To start with, regarding the aligned megaliths that you started with.
I can't hear you, sir. Hello.
Yeah, can you hear me now, sir?
Yeah, now I can hear you.
Okay. So, just a question on the megaliths that you had started the talk with. Is there any idea how they could achieve such precision in aligning? Are there any ideas of the equipments that were used in those days? Just a continuation on this, another question by the audience. is this, are there names of instruments for seafaring for determining directions, like longitudes and latitudes for navigation in sea?
Okay. Regarding megaliths, all that I would say is we really have no data on how they did it. We know the precision with which they did it. We also know the quarries from which they got the stones. We know how they cut the stones by digging cups in it and then lighting fire to it and making large slabs, and then carrying these slabs to wherever they needed to, and then erecting them. And our personal suspicion is that they must have used just a stick in the ground. A gnomon will give you reasonably accurate data about alignment. So they would have used a gnomon or an equivalent of sundial to be able to determine the directions with some precision. But a monumental amount of work would have gone in creating these thin slabs of stones and then carrying them to wherever they were carrying. So it must have been huge community affairs to set these things up. As regards instruments for using for traveling through the seas are concerned, they had a whole bunch of equipment to determine the speed with which they were moving and whether they were moving accurately in the direction. But it is not difficult to show that with simple pieces of wood tied to strings, etc., you could measure the speed with which you were going, and then if you had sufficient experience, you could actually calculate how much you should have traveled before you can go. But it requires some amount of arithmetic and some amount of knowledge of the speeds and some precision with which you must make these floating strings to know how fast you are moving with respect to the sea and so on. So it would have required a lot of experience because they didn't have too many sophisticated instruments, but it is possible to do that even today. So megaliths are one story which are phenomenal in the sense of the sophistication of the organization which would have been required to set up these megaliths. And seafaring is a question of experience and trying to understand a whole bunch of relatively straightforward instruments. But yes, those instruments are there and they are listed. Yes.
Thank you, sir. Thank you.
I must thank both of you for these two wonderful talks, which discuss various aspects, fascinating aspects of Indian astronomy, going from mere observations to rigorous scientific calculations. So, and also this provides an opportunity, not just mere observation, but touch upon history, stories, and mythology. So, just going back to your discussion, Professor Vahia, on megaliths. I mean, so do our ancient scriptures say something about?
No, because by the time the scriptures come in, they realize that a simple gnomon or a string in the ground is enough to give you all the sophisticated data that you need. They realize that a little later. Once you have a stick in the ground, you can get a lot more data. So the megaliths were not required for detailed astronomy by the time the Vedic literature comes in. But even if you look at the temple architecture today, they have this Dvaja Stambha at the entrance of each temple. And it is that Stambha that is put in first because a year-long study or even a few weeks of study using the shadow movement of that Stambha will give you all the directions that you need. And then you can build your temple orientation depending on exactly what you wanted. So some temples are oriented exactly east-west. Some are like the Marthan temple in Kashmir is oriented in such a way that during the harvesting season, the idol would be lit and so on. So you could do all that with a simple stick in the ground and a fairly complex marking technique on the ground. And once they realized that, the idea megaliths were no longer required to keep track of the movement of the sun. So by the time of Rigveda, it is sufficient. I think they would have realized that sticks in the ground work as well as the large megaliths. But the megaliths have their own uses.
Okay, so the next question is to both of you actually, because the moment you talk about Indian astronomy, so you have, as I said, history, story and mythology both connected. Is there any initiative rather than from a personal perspective? Is there any systematic initiative for this knowledge system so that one has a rather integrated resource platform for a common man? Because what we can see from the comments on social media, following your talks, they have very many questions. But is there systematic which brings it to more popular level, but more founded on logical analysis and scientific ideas. This is to both of you.
Yeah. So would you like to answer or should I answer?
Okay, I'll just tell something.
And then I can come in.
Yeah, Professor Bharatwaj's question about ancient Indian astronomy, that means the having a kind of archive in which all the information and data are contained. So in this respect, I will tell that there are some excellent books, and particularly there was a book published by the Calcutta University Press in 1947 by Professor P.C. Sengupta. He was a very well-known professor of Indian astronomy of Calcutta University. Now that book is unfortunately not available in India, but you have to get it from Chicago. So as it happens with many old things, we have lost. But I think all these books which I have come across with, they are generally not for common people. One must have some amount of or reasonable degree of knowledge in astronomy to follow such books. So therefore, I think I wrote one book primarily for common people, students and persons like us who are not experts in the Vedic and other literature, which is extremely difficult to understand even by regular Sanskrit scholars, but also the details of astronomical, positional astronomy knowledge. But I think work has been started, and as the interest in ancient Indian astronomy and its various aspects are being gradually increasing, so therefore I think some books, articles, they have started appearing, and maybe in the near future, a place like IIT Kharagpur can put a good archive collecting all the information at one place, where I think one can do more research on this. There are many things which are very peculiar and a lot of research is needed. For example, in Rig Veda, the earliest Rig Veda, the Venus, the Shukra Graha is named as Vena. Now, whether this Venus in Hellenistic astronomy and Vena in Vedic astronomy, a few millennia before that, what was the connection, or it is just a coincidence? Similarly, the Rig Vedic text or sloka which tells the direction of the south by connecting the Alpha Canis Minoris and Alpha Canis Majoris, and these two stars are described also as dogs in Rig Veda. Whereas in Hellenistic astronomy also these are called dogs. Whether these kinds of matching or coincidence is purely accidental, or there are some forgotten connection with European astronomy of our ancient astronomy in India.
Yeah, I have been asked to terminate, wind
Yeah.
up the session.
Can I just quickly add?
Please, yes.
So there is one book for common readers that we have published through National Council of Science Museum in Calcutta, which is I think is available for free distribution. Another thing, one is that with Ram Subramaniam, we have created a handbook of archaeoastronomy in India. If anybody writes to me, I can send you the PDF of that book. Plus all our articles, etc. on tribal astronomy are available on public distribution. So you can go to either academia.edu or go to ResearchGate or simply look for Google Scholars. You will find all our work on tribal astronomy and all our work in astronomy essentially available as freely available. But there is a popular book that we have published through NCSM, and there is a handbook of archaeoastronomy which is more technical, which we have published with Ram Subramaniam and others at IIT Bombay. And both these books are available by PDF. If you write to me, I will send them to you.
Yeah,
okay, thank you.
There have been many questions pouring in. I will request the audience to please email your questions to the organizers. The email is available. It will be made available again. Please email your questions. We will circulate your questions to the speaker and get back to you again. We are really running short of time. I would like to thank both the speakers for taking time off under such the circumstances, difficult circumstances, to take time off from their daily routine and present talks here. Thank you very much, Professor Wahiya and Professor Ghosh. Thank you very much.
My pleasure, entirely my pleasure. Thank you. Thank you very much.
Thank you very much.
So this has been astronomically appealing and astronomically fantastic. I mean, this whole session, and sir, your kind presence is like a blessing. And I think you know the ministry has agreed to give us a center of excellence on Indian knowledge systems. So I think such a center can only start with your guidance, with your pointers, and with your blessings, which is the most important thing. So with this, I thank Professor Somnath Bharadwaj and his team to handle this session so excellently, and we move on to the session before lunch, which is the technical session 7, Prakriti Vidya, which is on ecology and atmospheric sciences. So ultimately, the relationship between the sun and the earth, the relationship between the moon and the earth, the cycles of the seasons, the changes that we have on a daily basis, on a bi-monthly basis, or on an annual basis, or over hundreds and thousands of years, finally make an impact on human civilization over time, which is ecosystem, which is climate, which is atmosphere, and the making of civilization itself. So to handle such an important platform, we have one extremely esteemed and well-known professor of IIT Kharagpur, Professor Anil Gupta, who needs no introduction. Professor Gupta has been chairing, heading, and monitoring various institutes within India and abroad, and he's a fellow of various organizations, and currently he is the head of CODAL, which is the Center of Ocean, River, Atmospheric and Land Systems. But that's not what he is only, and he has been the guide and the supervisors of so many other students and scholars who have become great professors right now. So I'll request Professor Gupta to take this session, and he'll be assisted by Dr. Pranab Dev and Dr. Bharat Aithal of CODAL and the Ranbir and Chitra Gupta School of Infrastructure Design and Management, respectively, to monitor and oversee the two esteemed speakers, which is Professor Arunendu Banerjee, Director STS Systems, and Professor Onkar Mohanty from Orissa, advisor to IIT Bhubaneswar, and also advisor and involved in various institutes. So it's our honor and pleasure to give the mandate of this session to Professor Anil Kumar Gupta, IIT Kharagpur. Thank you so much, sir.
Thank you, Professor Sen. Giving me this responsibility to chair a session of about 1 hour 10 minutes. We have two lectures by two very eminent researchers, one by Professor Arunendu Banerjee, as you have said, and the other one by Professor Omkar Nath Mohanty. You have rightly said that astronomy and atmosphere, they are very closely linked. In fact, astronomical cycles have played, you all know, major role in driving climate at centennial and millennial time scale. So I'm sure the speakers in this session will present our treasure, what Indians have done in the past. I will, before I hand over to the speaker, I will start with a quote from Ramayana that says, Navamas dhratam garbham bhaskarasya gavastavi pitva ras samudranam dayo prasute rasayanam. Valmiki ji says in Valmiki Ramayana, for 9 months, the sky drank the ocean's water, sucking it up through the sun's rays, and now gives the birth to a liquid offspring, the elixir of life. So Indians have done, you know, through our literature, even in not only in Ramayana, but Gita also speaks about trees, about Himalaya, about Samudra, about different aspects of nature, even about the movement of sun, Uttarayan versus Dakshinayan, Shukla Paksh versus Krishna Paksh. So we have had treasure of knowledge about nature, and that unfortunately with time we lost. But I'm sure this initiative by IIT Kharagpur will surely add to or try to reclaim the treasure of our rishis and our researchers. So I would request the first speaker is Professor Arunendu Banerjee, and I will introduce him in brief. He is a consulting engineer and environmentalist. He's a designer, landscape. His main expertise in landscape gardening and planner. He has been author of numerous books on Gurudev Rabindranath Tagore, Swami Vivekananda, Jagdish Chandra Bose, Ratindranath, and and numerous other luminaries of West Bengal. He's a visiting expert to our IIT, and he has been member of numerous advisory boards in different parts of our country, and also museum. He has worked on riverbank ecotourism project of government of Assam, and also in other projects. So I invite Professor Banerjee to please enrich the audience with your presentation. Professor Banerjee, Professor Arnand Banerjee. Please unmute your mic, Professor Banerjee.
Yeah. Is it possible to listen to me?
Yeah, you can put on your camera also, video camera.
Yeah, okay, that. Okay, fine. I'll do that. Is it all right, sir?
No, sir, we don't have your video yet. Yes,
Yeah,
now it's
we
fine,
can
sir.
see- yeah,
Yeah,
it's okay, yeah.
Fine.
we can
Is
see.
it fine?
Yes, yes.
Fine. Namaskar. Pranam for everyone present today, and Honorable Professor Amit Gupta chairing the session in presence of distinguished professors, guests, and scholars. I'm deeply thankful to the organizers, IIT Kharagpur, the respected director, and the professors sitting here, for arranging this most relevant and important symposium, and of course giving me the kind of opportunity for presenting my paper, Arannyak Sriti, Rational Heritage of Human Ecology. Rig Veda, our own natural stream of knowledge, the higher order of realized truth in natural life system, are moving through the life-full civilization of India for thousands of years in search of the harmony. The great heritage of humanity, conscious, rich, rational heritage in Rig Veda, is also the wealth of natural science and art of life and living. At the earliest stage, Veda was referred to as Shruti Vidya. In the segments like Shanghita, that is Sriti, and Arannyak, that is culture, wild in forest, are the part of the pillars of Veda. Their interrelations are also the eternal religion of humanity, where elements of nature and earthly beings are in unity. India's own ancient knowledge of elements of natural science, as expressed in Rig Veda, are the strength of rational ecological studies and also relevant for the present world now in the crisis of environmental civilization and health, hygiene, both physical and mental. Basic consideration to know and to make known are the twin cultural civilization flowed like the eternal river, the Ganga. The culture life of modern human knowledge in India. Bharata-Tirtha is that inspired and eternal civilization of unity of universal rational ecological human heritage. Equilibrium and synthesis are centered in truth of realization and also in practice. The vision of poet Shatyadrashta are expressed and experimented in harmony for the studies of science, art, and culture, both in traditional and of eternal treasures of the knowledge of modern India. Atmosphere of freedom of mind had created the pilgrimage of welfare in progress, in equity, in our life of interdisciplinary knowledge and wisdom. Rabindranath looked at the path of Vedic ancestors, inspired by the tropical sky, with its suggestions of an uttermost beyond. Companionship in poet's mind thrilled with the presence of wonder of clouds hanging heavy with unseen rain, of the sudden sweep of storms arousing vehement gestures along the line of coconut tree, the fierce loneliness of the blazing summer noon, the silent sunrise behind the dewy veil of autumn morning. Such inspired truth comes to our daily life as splendor of greater Him, creator of earth. The air and the starry spheres sense the power of comprehension within our mind, the free, universal mind, both in the form of Sriti and Shruti in continuity. Kalidasa's Shakuntala is a creation from the basic elements of nature's own life in the purest natural forest hermitage, where all creatures find their protection of love. Aranyam, life of forest culture, of green, peace, harmony, of land, people, and environment, is a sharp contrast of the pompous, heartless life of king's court and palace. In Ramayana, having lived in the forest, Ram, the lover of the mountain and the forest, said once to Sita, "When I look upon the beauties of the hill, the moving life of nature's own life, the loss of my kingdom troubles me no longer. Nor does the separation from my friends cause me any pang. The exile in woodland transformed into the hermitage. The love to each other not only united them, but to the universe of life." Rabindranath, in The Religion of Forest, explained when Sita, the eternal friend of forest, was taken away, the loss seemed to be so great to the forest itself. On the departure of Vivekananda, as described by Romarola, in the end of a journey, profound courage and originality, Vivekananda. So life and work in East and West, the master of unity was living like a ascetics, Shakuntala, surrounded by his favorite animals, dog Bangha, she-goat Hongshi, the kid Matru. With them, he is to run and played like a child. An antelope, a stork, ducks and geese, cows and sheep, under his favorite mango tree, in the river bank of Ganges, in the Belur monastery. He almost led a village life in the lap of nature, also singing in his beautiful, rich and deep voice, taking Vedantic classes for the students, teaching methods of meditation and the importance of discipline in life. Cleanliness is the holiness. Also cutting drains by his own hand, expressing his dream for the creation of Vedic institution for future man making education, lovingly mingling with the groups of Shantals, walking in the land of Mort and talking to them, sometime weeping in sympathy, realizing their sorrows and poverty, serving them food in his own hand. He said, we have to relieve their miseries. That would be the sadhana of modern India, going into village to village. Thoughts of people's education, health hygiene, and upliftment of women power were in his mind and action till last days of his heroic nature of fullness of life. This is his life. Started like warrior prophet, cyclonic monk, with great message of unity, traveled through hills, forests, villages, and cities of East and West for the universal call of the earth, the religion of mankind. Thus sprung anew the conscience of India, the magic bard, faith in our unity, and in great message brooded over from Vedic times, driving the spirit of welfare for the mankind in natural unity, to build the habitat of mankind, also the souls of its inhabitants as well. Vivekananda said with profound conviction that the Vedanta of the forest world would now be brought into the life and practice of modern India. This would be our glorious goal now. Vivekananda was the personification of the harmony of all human energy. We need to embrace this very spirit in practice, in daily life and living. Designed for regeneration of fullness of life, which is now very much needed all over the world, all over the globe, by further innovation and authentication, following the path of Vedanta in life and practice. We will come to a great scientist, Jagadish Chandra Bose. Look at where he is starting. He said, "Oh, the great river, where from you have come to fertile our life of earth?" Our world scientist, Jagadish Chandra Bose, questioned his dear Bhagirathi river and got the reply in musical rhythm, "Mahadeva ek chota hote." From Shiva's matted hair, the message and lyric of natural art science, the essence of Prakriti Vidya, is still in the minds of every child in the country, all over through ages. But this is also natural and ecological science and art. This is in consideration of the 1,000 years of popular mythological concept of epic India also. We know the sun lifts the sea water to make the cloud, the air, in the air, and to make rain and snow or ice on the Himalaya that melts to come down as rivers. But this was known to the child, every child in Doors to Doors. In his popular science article for children, Story of Trees, he recalled the spirit of Ananda he enjoyed from the Prakriti's life and living in his very young days in village. Loneliness of life suddenly disappeared when he started talking with the natural surrounding, natural life. Love for trees, birds, flowers, insects, and butterflies started emerging as the fountain of inspiration. Every day he could observe the prana, the dynamics of natural life in science, in silence, expressed in the drama of progress in nature's own life. This is India's own Prakriti Vidya, the property of vastness, of environmental ecology, nature's touch of infinite possibilities, led into making of mind of a great natural scientist in future, discovering the basic unity of life. India's own intellectual freedom of science was achieved by founding modern Center of Science Boshu Vigyan Mandir, now internationally known as Bose Institute by Jagadish Chandra Bose. When our country was under the colonial rule, the spirit of freedom of mind opened the door to the center, to the united world of knowledge. The Temple of Science was inaugurated by singing of a Vedic song, followed by recital of invocation of sutras in Sanskrit. Rabindranath had specially composed a song, Matrimandir Punnangal, meaning the holy center of Mother's temple. Jagadish Chandra read his paper that day, The Voice of Life, which was known to him from the childhood in the nature. And he said, the Temple of Science is dedicated to the feet of God for bringing honor to India and happiness to the world, said Bose while opening the door of culture of science to the world. India's own ancient philosophy of rational heritage, of scientific humanity, flowed into the modern world of mind-minded knowledge. Patrick Geddes, world-renowned environmentalist, the friend of India, and close associate of Vivekananda, Rabindranath, Jagadish Chandra, and Gandhiji, wrote the famous article, The Indian Temple of Science on Bose Institute. He had also written the biography of Jagadish Chandra in English and translated in German. A British editor wrote in Jagadish Chandra, the culture of 30 centuries has blossomed into a scientific brain of an order which we cannot duplicate in the West. Nivedita, Nandalal Bose, Shurenkar were the designers of this unique Indian architecture and symbol Vajra. With the grand vision of Jagadish Chandra, a relief sculpture of Nivedita, Lady of the Lamp, is placed at the entry pedestal. If we come to Devendranath Tagore, the philosopher father of Rabindranath, always believed that nature expresses the profound truth, but India is a maker of realized truth into a built reality, that is Shantiniketan of Devendranath, the father of the philosopher, father of the poet. He has created the Shantiniketan village, the green peace ecology. The world was created from barrenness to built green, away from chaotic city of Calcutta, now Kolkata, where the public health and mind of city were suffering the decay, where the public health is facing the decay. They didn't stop there. Humanistic, scientific, and spiritual truth in unity of human ecology made the landscape of Shantiniketan for a school for Rabindranath. Later on developed into Vishwa-Bharati, the canvas of reality of Bharata-Tirtha. World's nest of creative unity is realized in the land-based learning center and rural reconstruction, and for the welfare of the village and villages. It may not be out of point today if we discuss that from Sriniketan, the epidemic was handled by Tagore and the fellow workers. Scientists from Johns Hopkins, All India Institute of Hygiene, India, and the scientists and workers in Sriniketan, they put together their mind and hand and the spirit of handling the epidemic, which is very contemporary today. Now the Prakriti Vidya is also spread and
Professor
appeared.
Banerjee, you have 2 more minutes, so please, I would appreciate if you, because we are running short of time, we have next speaker also.
Yeah,
so we appreciate if you complete your talk in 2-3 minutes.
Yeah. We will. Yeah, it's okay. Fine.
Thank you.
Now this. Thank you so much. Thank you so much. The Prakriti Vidya reappeared in ashrams' lives also, in the friendship of natures, in songs, dances, and drama. Autumn festival, spring festival, rainy festival, celebration of motherly water body also enriched plough and tree planting festival. Vedic stotras and traditional alpana art of Rangoli in Pranam Vedi continued as upasana of nature and man, as essential part of education and livelihood, participated by the eminent scholars and dedicated workers, both folk and tribals, of East and West. This society created the Vishwabharati. We are ending with a Rabindranath's song offering, Gitanjali. The poet prayed for more life, my Lord, yet more, to make my vision pure. In the same period, in the West, poet reminded the world on the realization of individual to the universe, in the realization of life. In his lectures, Sadhana also reminded, it's very important, that the ancient scriptures of India are of living importance. Their significance in the life and living world of universal nature is always in harmony with daily life. That is our future Bharata-Tirtha. Namaskar. Thank you.
Thank you, Dr. Banerjee.
Professor Gupta, just may I request you that actually Professor Banerjee has to leave, so 1 or 2 questions for him can be done at this moment.
Okay. So, Pranav and Dr. Bharat, please.
So thank you very much, Professor Banerjee, and it's a pleasure to hear you again. So on a different occasion and a different stage. I don't see many questions on the platform. Maybe they are now more convinced about what you have said. So that's what I believe. So thank you very much.
I have one suggestion, or maybe question or suggestion, but I am a small person.
Not at all.
Dr. Banerjee, we quite often young people call Ganga as Ganges, and I heard you also calling Ganga as Ganges, which is not proper actually. A proper noun cannot be spelled in a horse, has to be horse. We cannot call it as something like this. So Ganga cannot be Ganges, it has to be Ganga only.
I have said Ganga only, and if you remember correctly, and in the starting, and of course for the popularization, say like that. But Ganga is a word, symphony of the civilization of India.
Thank you. Now we have, thank you so much. As Bharat has said, we will have your lecture maybe on some other occasion. So the next speaker is Dr. Omkar Nath Mohanty, and he's going to speak on a topic related to atmospheric science. And thank you, Professor Banerjee. Thank you so much.
Thank you so much.
See you again.
Yeah.
Namaskar. Dr. Mohanty, please unmute your mic. Dr. Mohanty.
Yes, I think it's unmuted. So I'm visible now and probably audible to most of you. So first of all, a very good afternoon to everyone present here. And I must begin by thanking the organizers, above all Dr. Anuradha, who is present here, for having roped me in here. And it is always a pleasure for me to come back to the forum or the platform of IIT Kharagpur, where I spent 22 years of my life.
Dr. Mohanty, I'm sorry, actually, in hurry, I forgot to introduce the speaker.
Not necessary.
No, in brief, I would like to say a few words. Dr. Mohanty is a BTech and MTech from our institute. He is our alumnus. He did his PhD from University of Karlsruhe, Germany. He is visiting our IIT, and he has been he has taught at IIT Kharagpur. He was a vice chancellor of Biju Patnaik University of Technology, Odisha. He has lots of academic credentials to his CV. He is a fellow of Nasi, Allahabad, and then besides he has achieved numerous other recognitions. So his research contribution has been primarily in the area of structural property correlation in metallic materials. So he's basically a metallurgist, and let us hear him about atmosphere. A metallurgist turned to atmosphere will give us something new about the science. So, Dr.
Thank you.
Mohanty, please.
No, since the time is running out, I thought I'll move fast now. No, it's not about atmospheric science. The title of my talk, as you will soon see, is primarily on the metallic materials that existed in India, how they are manufactured, and some of the iconic structures of India I'm going to take up during my talk, and that's what I'm going to deal with. And you will give me 1 minute when I'm sharing my am I visible now? Or at the
Yes, we can see. You can have it in slide mode, please.
Is that right?
Yeah, it is visible.
If it is visible, I will move further. So therefore, there is a small modification. I had given this title, Metals in Ancient India, Iconic Iron-Based Structures. Before I begin, I think there's an apology here that unfortunately, this has not become a full-fledged course in India in any of the universities as yet, in the undergraduate and postgraduate degrees. At IIT Kharagpur, we have made an attempt to teach it thanks to the humanities department, whereas in IIT Bhubaneswar, it's a longer course. It is taking shape as a course. Whereas a lot of research is going on in India today, primarily at Banaras Hindu University, at NIAS in Bangalore, and so on. I'm going to talk about the structures, the iron-based structures, but before that, I will talk about the basic metallurgical structures which are there in India. I am not able to move the slides. Yeah. Interestingly, when we talk of the metallic materials in India and the structures, we have always thought that steel and other metallic materials came from the West, and the Renaissance anyway mostly started there. Industrial revolution took place there. So people tend to believe that whatever we have today is only from the West. May I also remind my extremely worthy listeners who are here that in the 18th century, up to the 18th century, India's contribution to the world economy was above 20%, whereas right now it will be less than 0.5%. Such was actually India's dominance in the past as far as the economy was concerned. And in the economy, even the metallic materials also occupied great amount of recognition. This is an interesting slide I thought I would share with you. When we are talking of India's contribution, I think it is important that we should also know that there are very interesting foundations here in India. One of them is the Maharana of Mewar Charitable Foundation that actually recognizes people that have done work on India and Indian archaeology, Indian science, Indian literature, and so on. And it so happened that in 2018, the gentleman or the scientist who got award was, the award is called the Colonel James Todd Award, but the award this year, 2019, was given to or awarded to Dr. Paul Craddock. And Dr. Craddock has just retired from the British Museum. And Craddock has been working in India perhaps for 20-25 years, although he has been associated with the British Museum. And he has done a lot of work on early metallurgy in India, primarily in Western India and Rajasthan. I am facing problems.
Sir, due to network, it may be a bit slow, sir.
Yeah, I think there is a network problem. So, but anyway, let me quickly now go through. Yeah, now it should move. So what we find is 2019, Colonel James Todd Award, British Museum. So that award was given to Paul Craddock. And in this figure, this is very interesting because we are actually holding the seminar, I understand, as a part of the NEP, the IKS, the Indian Knowledge Systems, and so on. And one of the authors of the Indian Knowledge System has been Dr. Kasturi Rangan. And you'll find Dr. Kasturi Rangan also in this figure. And Kasturi Rangan is standing here, along with the Mewar of the Rajasthan. So this is Maharana Arvind Singh Mewar, and his son is there, Lieutenant Paul Craddock and Dr. Kasturi Rangan. So Paul Craddock has a very interesting statement to make. He makes a statement that the Industrial Revolution, people believe, happened in Europe, but it couldn't have happened in India. This is the usual refrain which people use. But according to him, and many of us would like to tend to believe that the Industrial Revolution way back in countries all over the world it started, and particularly in India. So he said that, well, there are quite a few things, metallic materials, which are invented in India, but they would believe that, well, they were made in small scale. But then this man goes to show, he has proved to the rest of the world also, like many others, that India was actually the birthplace. But the problem with Indian metallic materials was the mass production. The mass production was the issue, whether it was the zinc or the copper or particularly iron, where that is how we lost ground. So basically Craddock says that this is a prejudice, which is still in the Western mind, but the Western mind still tend to believe that it is the Western world. So from there, we will not go here because you don't have much time, I know. We'll go to the metallic materials from Stone Age, and when we talk of the Chalcolithic age, native copper started not just in India, in China, in Egypt, in many other places, in India also. But the smelting of copper started from malachite. Interestingly, many of these the copper ores, that is malachite, contain also arsenic. So you'll find it is not just the copper, but along with copper, the Bronze Age also started. But that bronze, as all material scientists should know, the bronze definition is copper plus tin. It's an alloy. But this particular bronze that India started with was not a copper plus tin bronze, it was arsenic bronze, because the arsenic occurred naturally in the ore itself. And the tin bronze, which is a more classical bronze, started around 3000 BCE. Unfortunately, I have put them on BCE, but it is same as BCE. So 6,500 years back, the smelting of copper started. Some of the native copper was already there in 8,000 years back, etc., etc. And then the smelting of iron started only around 1200 BC. So along with Stone Age, and these are all the Paleolithic sites in India, we don't have time for that. Gold and silver in southern part of India, in Karnataka and Maski region, we all know that the gold mining was going on for quite some time. But all over India, when you talk of not far from Kharagpur, is the Suvarnarekha region, and the name Suvarnarekha itself would tell you that in this region, the villagers were still actually collecting gold because of the name Suvarnarekha from the river Suvarnarekha, etc., etc. Lead, it is now known that the mineral-rich Aravali region of Rajasthan was one of the important early lead mines anywhere in the world. And although it was also occurring in the Egyptian region. Mercury, our people were using mercury already. The vermilion or cinnabar, which is nothing but mercuric sulfide, has great ritual significance, typically having been used to make red bindi or dot on the forehead of Hindu women. But the mercury figured prominently in the Indian alchemic tests, you'll find. And ingeniously in ancient Chinese tombs, the cinnabar also used to be used. Zinc, the most important thing about the zinc part is, in zinc we don't have to prove much that India has been the place of zinc manufacturing by distillation process. And at IIT Kanpur, Professor Arun Biswas did a wealth of work. And then, of course, I mentioned Professor Dr. Craddock from British Museum. So it is already established that India had preeminence in zinc. And tin was not exactly occurring in India. There were only pockets of tin. And some of the ores of tin which are there in India, including that in Odisha, in the southern part of Odisha, where cassiterite occurs, but they are not working as yet. So Malaysia was the place where tin used to come from. And but those of you who have been to Kuala Lumpur, you'll find actually many of these abundant mines. That was the tin. Bronze alloys I have already talked about. In Mesopotamia, you'll find the bronze alloys, and in India, one would find the bronze in many places. This is one of the bronze as well as brass. You'll find brass is copper zinc and bronze is copper tin. Now, copper tin, Nataraja, the lost wax process, which we call a lost wax process. Today, most of our aircraft components and so on, they make use of lost wax process. But think of the time when Indians were already using the lost wax process of casting some of the icons like one of these. Just to summarize what I have said so far, in the early period, the X is 10,000 BC, and now we are talking of 2020, and that's the year when we are in. So you'll find various metals which are occupying high positions of recognition in the society. They actually went down gradually, and then what are becoming very important today, if you go to IIT Kharagpur Metallurgy Department or the Metallurgy Material Science in Bangalore or to Cambridge University, you'll find people are mostly working not in metals, but the composite materials, nanomaterials, and so on. But we will now start the iron part, and I would like to quote Rudyard Kipling. Gold is for the mistress, silver for the maid, copper for the craftsman, cunning at his trade, etc., etc. But iron, cold iron, is master of them all. I also would like to remind that in 1953, when the National Metallurgical Lab in Jamshedpur was inaugurated, where I spent 11 years before I joined Tata Steel, C.V. Raman was supposed to come. He couldn't come. Jawaharlal Nehru was inaugurating, but C.V. Raman's letter was being read there. So he said, I salute iron because it stoops to conquer, it bends to conquer. Goldsmith's famous book, which says it stoops to conquer, he turned it slightly, C.V. Raman, and said, it bends to conquer. So the bloomery iron and iron technology was the most important thing. And it is quite odd to think of the fact that Indians, this is an important statement I wish to make. Indians, as Indians, we did not know how to melt iron or use molten iron and cast it. But we knew how to make excellent iron in the days of yore. And that's essentially because it was a solid state of iron making. Basically, what one would do is you mix the iron ore, small chips, and then the charcoal, which was the burnt wood, and mix that together. And if we heat it up, the primary reason why you couldn't melt was we did not know that the iron would melt at 1538 degree, and then you add another 60-70 degrees in order to make it flow. We knew all that, but we didn't have the refractory materials or the mold in which you can actually melt it. So that's the reason why molten iron was not being used. So far, we have not discovered a single site where molten iron was used. So what were they using? They were using this mixture of the iron ore and the charcoal, heat it up by 1250 degrees, not at 1700 or 1650, by 1250 degrees already. Some of these slags, along with iron oxide and silica, they will have a lower melting point. So you will have a fused mass. The iron oxide is already reduced, it has turned iron, but the iron has not melted because the temperature is not reached, but the slag is there, so you get a fused mix, and it mix, they used to take out and then start hammering it. When you pound it with the hammer and the slag will be squeezed out, what remains is wrought iron. Incidentally, it is the same wrought iron with which the many of the towers of the world, they were actually constructed, because that was the standard practice. So sources of iron, the world knew the sources of iron. They had never seen actually iron until about 1200 BC. So the Eiffel Tower in Paris, which we see today, is primarily made out of the wrought iron. And it was called wrought iron because we are starting hammering the fused mass. This is the typical meteoritic iron or meteoric iron. And here, this is a big chunk. There are chunks of meteoric iron which were actually collected from Greenland, kept in the New York Museum today. So I don't intend to go there. So the first step actually is mixing the iron ore, etc. We don't get into that. There is a timeline which I wanted to, but I'll skip this, except to say that the Iron Age started when Indians started using some of the iron beams in the temples. But much before that, by 436 AD, the pillars, which were essentially as a tribute to the courage of the Indian kings, that is why many of these pillars were built. And the oldest amongst them is the Delhi Iron Pillar. We'll come to that a little later. And all the iron mills started, etc. So these are some of the remnants. If you went today to this south part of Odisha, in Koraput, Chhattisgarh area, and many areas of tribal areas of West Bengal, not far from Kharagpur again, you will find some of these ancient iron making processes still there. And what they are pulling is actually, basically there will be bellows and they will let air inside in order to burn the charcoal. And the kind of implements they were making, they were rather primitive. These implements are still being made near Ranchi and in Bastar area in Chhattisgarh and in Koraput area. So you'll find some of these implements still there. Now, interestingly, I would like to take a page from Rig Veda and the the Hindi translation of the Sanskrit. I don't intend to read it, although I love reading it to the students, essentially because of the fact that it tells you that how the mixture is made and how, in order to make from low carbon to the high carbon, they would act actually essentially the furs of swan. That's what is written here. I can read out in Hindi. Carbon की मात्रा बढ़ाने के लिए शकुन यानी हंस पंछी के पर भी डालते थे. हंस के पंख में 90% बाष्पशील द्रव्य और 10% कार्बन होता था, वगैरह वगैरह. So that is how they were increasing the carbon. The other thing I wanted to tell you is in the scriptures, Rig Veda and particularly the Yajur Veda and Atharva Veda. Atharva Veda, you will find some of these Atharva Veda scriptures are there in Odisha, Bengal, Bihar, not now Bihar, Chhattisgarh, Bohda Goda area. You will find some of these Atharva Veda scriptures. And what it shows is from extremely low carbon iron to extremely high carbon iron, we have the Sanskrit names of that. Extremely low carbon iron, which we call the soft iron, and soft magnetic materials from the Varmaka to Chumbaka, to if you go to cast iron, which will contain 2% iron, this will contain about 0.01% iron. And we had Kadara, Kunda and Mridu. So therefore the Sanskrit names are already there for these extremely high ones. I now take you to a beautiful temple not far from where I live today, and most of you or many of you would have heard this name, Konark Sun Temple. And the Konarka Temple, if we take Rabindranath's sentence here, very interesting sentence he makes, here the language of stone surpasses the language of man. So this is the only World Heritage Site as far as Odisha is concerned, 1984. There are about 30 World Heritage Sites by UNESCO. Again, I have problem. So Konarka, those of you who would not be knowing, it is on the coastal area. So here is actually Puri. This is Puri. This is Konarak. And Bhubaneswar is somewhere here. That's where I'm sitting. So this is called the so-called Golden Triangle. Roughly from Bhubaneswar to Konarak is 65 kilometers. From Bhubaneswar to Puri is 60 kilometers. And the temple at Konarak is hardly 2 kilometers away from the seashore. And interestingly, where the temple has been built, this temple has been built, close by was a river. And the geology department of IIT Kharagpur, Professor William Mahanti, and the humanities department where Anuradha belongs and Professor Priyadarshi, they all work together, and they have actually traced the course of the river Chandrabhaga, which was flowing near the temple, which is not seen anymore, which is actually subterranean river. A word about the Orissan temple architecture, which was a very special architecture. Those of you who know about Rajendra Mitra's books and subsequently Professor MacDonald's books, a lot of things have been written about the Nagari architecture to which the Orissan class belongs. But broadly, to describe the Orissan architecture, the Sanctum Sanctorum or Garbhagriha, that used to be what is done here pink. But most important is, these are called the Rekha temple or the Rekha Deula. And that's where this is above the shrine. And you will find a curve there. On the other hand, the yellow part, these are called the Pidha Deula. That means steps were there. And this is like a pyramid. After a square part, up to certain height it is square, and then the pyramid comes. But no gods or goddesses or icons used to be placed here. This was for the audience. People used to congregate only there. So the Rekha Deula and the Pidha Deula, these are the main two. What I should have also explained, the blue part. The blue part is called the Khakhara Deula. So according to the scriptures, these are meant only for the tantrics and where the goddess used to be worshipped. So this is there in Bhubaneswar. Boitala Deula is a single example of the Khakhara Deula around Bhubaneswar. So every other temple you will find the yellow part, which is nothing but the Pidha Deula, and the Rekha Deula is where the Garbhagriha or the Sanctum Sanctorum used to be located. For example, I'm giving the Puri temple I'm showing to you. So you'll find these two. This is the Pidha Deula, that means steps are there. But where the Sanctum Sanctorum is there, that's all the Rekha part, the curvilinear part. I don't know why. Okay. So interestingly again, in Konarak what you see is not the main temple. There is no temple in Konarak today. The Sanctum Sanctorum, along with that, the main temple, which was about 230 feet tall, is no more. It has collapsed. So the temple came into being around 1250s, 1247 to be precise. And by 1740s, after existing for about 500 years, the temple had collapsed. People like Professor Bhattacharyya, S.K. Bhattacharyya, Sriman Bhattacharyya, who is in IIT Kharagpur, while he was in CBRI Roorkee, had done some work also on the collapse of the temple. So it appears to us that the stone temple, they used to have what is called a counterpoise technique for putting one stone above the other stone. So if the basement or the fundament, the foundation itself is shaken somewhat, so there is a river nearby and the seashore is hardly 2.5 kilometers. That is how the theory for the collapse of the temple is that it got slightly imbalanced and the temple collapsed. And when the temple collapsed, the 230 feet temple, which has been described by some of the Indian travelers in Aini Akbari, Abul Faisal has described it. English translation of that is also available, but that's all gone now. So what exists is actually the smaller one. I will come to that. So the temple was called the Black Pagoda because from the seafaring the travelers, it was appearing black, as opposed to the white pagoda, which was the Puri temple. So today what exists is only this. As you enter, this was also the Pidha Deula, that means the steps. This is the existing temple, but there is no God here. Right behind was the main temple. This is about 128, 130 feet, and this was called the Natya Mandira. And on Natya Mandira, there was also a roof here. The roof has also fallen. So basically, the last part from the temple which had fallen off was in the year 1860 or thereabout, where another super cyclone had hit this part of India's coast. Now, I just want to show to you, all of you know, of course, that the Konark temple has exquisite sculptures there. Now, 24 wheels, this is the only intact wheel, and every inch of this wheel is sculpted. And every inch of this temple also is sculpted, 130 feet from bottom till top. This was all underground, and around 1820, the British occupied Odisha in 1803. After 20 years of that, they discovered this temple. Then the excavation started. So this is how it exists today. Now the last part of this temple which I want to show is this. This is again a very interesting thing, because you find a giraffe here. So giraffe, India is not a natural habitat for giraffes. So what it signifies, and the historians are unanimous in saying that, the maritime activities that existed along the peninsular India, Odisha was no exception. From Bengal, from Odisha, from Tamil Nadu, from Andhra Pradesh, people used to go. So that is where they would have seen actually the giraffe elsewhere, and the merchants used to come back, and that is how they started sculpting the giraffe. So the whole temple was actually, the concept was a chariot, the sun god used to move. I will not talk about the temple very much. I will come straight, I will bring you to the iron beams which are lying on the ground. About 29 iron beams are lying. Now it has broken into about 32. That means 3 or 4 have been added. And these iron beams, they look plain as you can see. But interestingly, the dimensions of each one of them, roughly the largest beam is about 30 feet and weighs more than 7 tons. And the next largest beam is about 25 and 6 inches. What I wanted to tell you is, each one of these beams, the large beams, they are larger than Delhi iron pillar, and they are heavier than the Delhi iron pillar. And what were they used, the iron pillars? The iron pillars were being used. Today also you will be able to see this on the eastern side of the gate. You will still see the iron pillars in use on this gate. Now, I want to also tell you that when the British found that the main temple had collapsed and the 128 feet temple, which is the gateway, is existing, so they apprehended that this temple also would collapse. So they employed an engineer who came from Patna, 1904, and they asked him to fill up the entire temple with sand. So today all 4 doors have been closed, actually 3 doors, because behind the main temple was existing. 3 doors have been closed. From the top they have filled up the sand, and the sand has remained in place for 120 years. The question is, today what has happened to the sand? The sand has actually descended, as Professor Bhattacharyya and his group, they have found out by endoscopic technique. So today this is a very serious problem, because since it has descended, the sand once upon a time which was supporting the roof and therefore was a protector to the temple can today become a cause of the collapse of this temple as well, because it actually exerts a sidewise pressure. So, but that is actually the structural engineers. IIT Kharagpur is also working on this, so I will not talk about this. Site of the beam making. Do we know where these iron beams were being made? We do not know that. And what are the speciality of the beams? This is where I bring you to. If you look at the sides, the corners of the beams, and these are all my photographs, because I was not allowed to touch. You have to take a permission of the Archaeological Survey of India. So what you are seeing over here is that there are protruding portions, as if like a bamboo. There are portions which are protruding out of the beam. So I found that most of the history books are silent about it, and even there are some great historians who have worked, but they have not thrown much light or insight into these beams. What I found out in a small history book is, and if that is correct, then we have to believe that each of these beams, they actually comprise a large number of smaller plates. Over that, the hot bloomery iron is poured and hammered, so that there is a blending of all these smaller plates takes place, and it all appears as a single beam. So this is probably the only example of what we can call today a composite beam in India, composite iron beam. Why is this important? Hammering marks you can see there, but most important is, if you have a single beam, then if you put a heavy weight over there, because the Navagraha, more than 70 tons or 80 tons, which the mighty British government could not take beyond 100 yards, and they left it there. And today there is a small museum in Konark, you will see there. But that Navagraha, more than 70, 80 tons, was also resting on some of these beams. So why is it that the beam, which shows to me, my photograph shows that in some places they have not welded, because they were hammered manually. So when you hammer them manually, there are possibilities that you see these gaps. So there are welding gaps. Now, notwithstanding the welding gaps, what we find is the beam was still holding this weight, heavy weight, huge weight. And the reason is that, well, these are the microstructure composition, we can forget that. But the crack propagation property would be much higher if you have smaller iron beams, not beams, but blocks inside. That is why it was actually standing the weight. Now, I will switch to, well, the rusting which has taken place.
Dr. Mohanty, can you please come to the conclusion part?
Yes. So the iron pillars of India now, I switch over. Delhi iron pillar is the most important iron pillar. Incidentally, the American Institute of Metals, they have donated, not donated actually, they have given a plaque which is now placed for the past 4 years at the foot of this temple as a tribute to the human science or the contribution, but primarily Indian. So essentially why? Because 1600 years and it has not rusted. So books such as The Rustless Wonder That India Was, you'll find all around DIP. But this Delhi iron pillar was not existing in Delhi. It was actually existing in Madhya Pradesh near Dhar, and it was brought in the 14th century, early 14th century to Delhi. Essentially, now today it is existing in the premises of Qutub Minar, as you know. So we have done some chemical analysis and done some corrosion analysis. Now this is the work of Professor, another 2-3 minutes, Chairman Sir. So this is the work of Bala Subramaniam of IIT Kanpur, who is no more. We lost him when he was only 45 years old, about 8 years back. So Bala showed with very sophisticated analysis, there are a lot of articles, but this by far is the most sophisticated article, where iron hydrogen phosphate was occurring here, and that is why it was providing the corrosion resistance. Apart from Delhi iron pillar, we have iron pillars in Dhar, and but the Dhar iron pillar is much larger than Delhi iron pillar. Delhi iron pillar is hardly 24 feet, weighs about 6.5 tons. Whereas the Dhar iron pillar, which is existing in Dhar, is greater than 43 feet, 7.3 tons. But people don't speak of that, essentially because of the fact that it actually broke into so many pieces because it was actually like this. It was against the walls in 1980. Then subsequently, the Archaeological Survey of India collected, look at how the octagonal structures, then the rectangular structures, and the round structures, they were all connected together, and they were connected like this. They were connected, they were not dug inside the ground, but with iron wires. And these pieces were all joined together. These are the processes of joining. The next one is Mandu iron pillar in Madhya Pradesh. Again, Madhya Pradesh, but this is much smaller, and this is about 11 feet something. And then this is the Kodachadri iron pillar. One other thing I wanted to show to you, because without this, no work or description of the Indian iron and steel will be complete. Damascus swords, and this is the picture which you see. This, of course, is an artist's impression. And what you see here is with the special helmet and the headgear, that you don't have to spend much time in recognizing that that's on the left. Our left is Alexander the Great. On the right is Puru, the king from the Punjab. But Puru, having lost the battle, there is no remorse on his face. To the contrary, he is telling or passing on something as if to tell Alexander that you may have won the battleground, but I have won the war because I have the technology. Because we believe that what he was passing on is actually wood's metal, and from which the Damascus swords were made. For the past 300 years, scientists have been working. As late as last year, articles are still coming out, and these articles show that the Damascus swords had kind of watery marks on their surface, and they were very sharp. How did they have high carbon material, which is very, very brittle? How could they have this kind of marks? And at the same time, it was not brittle, it was very ductile. About 3 feet, 4 feet, and this is the kind of surface marks you have, but you run your finger on that, it is all smooth. That is what was a great mystery to the scientists and material scientists. We have today found out that it is, the summary is that these are actually the carbides of tungsten, carbides of vanadium, collected from the sands were from Karnataka, and in Andhra Pradesh and particularly Karnataka, this material was being used. Thank you very much.
Thank you, Dr. Mohanty. Before I pass the question answer to my colleagues, Bharat and Pranav. I have three questions for short questions. Number one, I have read Megasthenes of Indica, where nowhere he mentions that Kuru was defeated. You have just said that after the defeat of Kuru by Alexander.
Yeah.
So that is a controversial statement. The other one is about the metals. I see the metal cassiterite, which is the English word that came from Greek cassiteros. And this Megasthenes Indica mentions that this cassiteros was taken from a Sanskrit word cassitra. So many metals names were taken by Greeks, and then these were passed on to the Britishers. The other one, your statement about giraffe. We as a geologist, we know that giraffe roam through the plains of Himalaya and Shivalik plains and Shivalik hills. We have the evidence, the fossils of giraffe, which are as old as 1.6 or 1.9 million years, in fact, in the country. So giraffe has lived in the foothills of Himalaya and also in the Shivalik hills, which are the lesser Himalayan hills. So now I pass it on to...
No, before you pass on, I think let me react very quickly to the first two statements. I have nothing to say. You know, whether you lose a small battle and you actually win, the loss and the victories and losses, this is a matter of interpretation. I'm not going into that because I'm not actually a scholar.
No,
you are right. But I would tend to believe, because from his face we do find that he was a great warrior, of course. But the second part, which you mentioned about the names, I think most of the names of the ores, including Kondalite and so on, the Kans of Koraput and Bastar, from that the geologists use the word Kondalite. So I would tend to believe that yes, many of the Indian words of mines and by minerals, they have been taken by the Westerners and then given back to us. And we use the distorted name, yes. But when you come to the giraffe part, what you said is right, because the Gondwana land and the great continental drift that the geologists we have established goes to show when India and Africa were apart. So therefore, it is not surprising that actually some of these animals were actually moving in both places. But we are not talking of that age. We are talking of 1240s. By then, they have become extinct in India. That's what we are talking about, which is why the giraffe makes sense. Now you can go to the other questions.
Yeah.
Okay, thank you, sir. So, Professor Mohanty, thank you very much for this insightful talk. Lots of points to think about. Unfortunately, not many questions on the social platform forum. Maybe they will come in later on. But I have one question of my own. So, I visited the Cuttack Maritime History Museum a few months ago.
Sorry, which area? I couldn't hear which area?
The Cuttack Maritime Museum.
Yes.
So I was quite fascinated to find out the maritime history of ancient Kalinga and the ship-making technology they had. So my question is, what sort of metals, alloys, or technologies were they using while making ship, and what sort of impact it had on the Southeast Asian countries and in other parts of India as well? Will you shed your, something to say on that?
Thank you. So I will take only 2 minutes to answer your question. First of all, Pranav, what has happened is this Maritime Museum in Cuttack, unfortunately, is not a complete museum. It's not a complete museum because some of us, including 2 professors from IIT Kharagpur, younger to me, who have now retired and they have, like me, settled in Bhubaneswar. One of them is a naval architect, Professor Suresh Mishra. So what we are doing now is actually, the age of some of these exhibits which are there in Cuttack, they are very poorly identified. So we have to do a lot of work. So we are not even sure if some of those vessels which you saw, they were news or not earlier on. But the fact remains that they are next to the Mahanadi, and Mahanadi had many estuaries and also a canal which was going all the way to Paradip port. So now in the Indian highways, water highways which have started, so the new highways are now starting because some of them were actually, they were blocked, and the digging has started. But then coming back to what kind of metals you have asked. Now, iron and iron pieces were being used. Whether iron alloys, we do not know. So they were rusting. So from there we know that even in Konark iron and Delhi iron pillar, I didn't tell you about that. Why is it that Delhi iron pillar has not rusted and the Konark iron beams have rusted? Not very badly, but they have rusted. Number one, the phosphorus content in Delhi is much higher because the mineral was containing higher phosphorus. That has given to a better protection. But more important is the Delhi climate itself. The Delhi climate, if you look at the seashore, it is far away. And those days, earlier days, sulfur, phosphorus, etc., industrial atmosphere was not there. So therefore, and alternate immersion, etc., that's what Balasubramaniam has established. Due to that, the corrosion resistance was high. Now, what kind of other metals? Now, the merchants from Odisha who were going, I don't know if you're aware, every year in the month of November, around this time, lakhs of people congregate in Cuttack and a Bali Jatra takes place. The name of that Jatra is called Bali Jatra. And when I went to Bali myself year before last, and I went to the Jagannath temple in Bali. Of course, that Jagannath is very different from our Jagannath because they put the Lord on the top like a bird is guarding. But that's a different thing. People do say that Bali Jatra is the time when the merchants would to set sail for the Far East. And what were they taking with them? Odisha was very famous for silk and cloth, textiles. And also the brass, bell metal. And some of the Dhokra casting came much later. The brass and bell metal, and this they used to take. So the metals they were taking with them for the ship building or the boat building, they were using nails, and they have found that out. This is a very fascinating area in the British Museum, the kind of Scandinavian ships which have been discovered, probably you are aware, and they are the history of England actually, so to say. Not just England, but it is the history of Anglo-Saxons. So you'll find books on that. So if I have answered your question, that mostly iron in the shipbuilding.
Yes. Thank you, sir. Fascinating. So I'll request Professor Gupta now to take over and share his concluding remarks. Thank you.
Is there any other question from anyone?
No.
I on behalf of
Today is the theme is language.
Yeah,
okay. We got one question actually, just at the last moment, if we have time for that.
Sure.
So, what kind of iron were being used in Indian swords? That is the question that came up.
What kind of iron was being used in India? Now, by and large, the bloomery process used to make low carbon wrought iron, and which is where the Eiffel Tower and the likes were being manufactured. But when you come to Damascus swords, they were made from wood steel, high carbon iron of the order of 1.5% carbon. And 1.5% is primarily a kadai iron. If you see today kadai, go to the marketplace, you purchase a kadai which is a cast iron, drop it from a distance of 4 feet, it will break into fragments. Imagine a 1.5% carbon, same composition as a kadai iron. Our ancestors had converted them into the Damascus swords which Tipu Sultan was using, and the British were so scared of him, they brought actually a special machine from London in order to destroy all the Damascus swords that Tipu Sultan and his armory had. Fortunately, whenever I go to Bangalore, from Bangalore to Mysore, I travel, I make it a point to go to the Srirangapatnam and see that and salute always. I don't get into the polemics of whether Tipu was actually a patriot or not, but the kind of technology and this 1.5% carbon steel they had converted into this kind of Damascus swords. So coming back to the question, we had both low carbon iron, we had high carbon iron. So from extremely low carbon to extremely high carbon, Indians were well versed in making variety of steels. That is why I showed the Sanskrit words for the low carbon as well as extremely high carbon iron in between varieties of carbons. Thank you.
Okay,
so
thank you.
Can I just have one last question? Quickly. So it was just to ask, sir, that why is it that we lost, if we had this iron, this rustless iron technology, what is the reason why we lost that?
Anuradha, I didn't plant that question, but this is the question on the lips of most of the Indians, and they would say that the metallurgists of today do not know how to make iron because the current iron is all rusting, and Delhi iron pillar didn't rust. And so the interesting aspect is the phosphorus, when it is high, load carrying capacity of iron or steel goes down. So we make deliberately extremely low carbon phosphorus today with steel. So our ancestors are using the high carbon, like Delhi Iron Pillar, they were not they would not be able to carry extremely high load, and A, and B, their crack resistance will be low, and C, their toughness will be very low. Yes, we have produced, I remember having produced some high phosphorus steel in Tata Steel in the TMT rebars. But in order to do that, we have to take recourse to 3D atom probe to find out where phosphorus is at the grain boundary or somewhere else, and then put the phosphorus in the right place. Coming back to your question, therefore, that they were using the iron ore as it is because they did not have a technology for dephosphorizing. That means the phosphorus removal. So the phosphorus, I would say, inadvertently was high. Slag inadvertently was high because of the technique that we're using, and both of them, to a limited extent, will give us corrosion resistance, but will give us disadvantages in load carrying capacity and toughness and such other things. So why we lost that technology? We are not able to produce in large scale. I said it at the beginning. That is, of course, we lost most of the knowledge in textiles and metals. But whether we have lost the knowledge in the corrosion resistance? No. We have not lost the knowledge today. We know exactly what actually makes corrosion, what prevents corrosion. But we also have to compromise with trade-off between the corrosion resistance and the strength and toughness and ductility.
Okay, so we come to the end of the talk, and I, on behalf of the organizers, Professor Somesh Kumar, Professor Joysen, Anuradha, I thank both the speakers for their thought-provoking presentation and wonderful talk. We all, audience, got enriched. I also thank, on behalf of IIT Kharagpur, both the speakers, and hope to listen to them in future again. And before I hand over, I will read a quote from Samrat Ashoka, who said, "I will change, I will no longer be known as the evil Ashoka, but as Ashoka the angel." He evokes in his life as a child, as he suffered, and then he became Chand, and then he became monk. So he has 4 steps. So I pass it on to the organizers. Please
thank you.
Tell about the next course. Somesh, please.
Thank you. So first of all, let me thank Professor Banerjee and Professor Mohanty for their excellent talks, and it was very thought-provoking, and a lot of discussion took place. So it shows the kind of effort that has gone into preparing the slides and making the very informative talk. I thank both of them on behalf of the entire IIT Kharagpur fraternity. And as we have already now know that we are going to have a Center for Excellence in Indian Knowledge Systems, we will like to have both of your expertise in this. I thank Professor Anil Kumar Gupta for handling this session very nicely and also asking a lot of thought-provoking questions. And I thank the rapporteurs, Professor Pranav and Professor Bharat, also who have coordinated the session. So this brings us to the end of this technical session 7 on Prakriti Vidya. We will have a short lunch break, and at 2:40 we meet for the technical session 8 on Nandan Tattva Tatha Vastu Vidya, which is on archaeology, iconography and architecture, followed by a panel discussion in which we have 3 eminent persons, Professor Anil Sahasrabuddhe, who is the chairman of AICT, and 2 of our former directors, Professor Shishir Kumar Dubey and Professor Amitabha Ghosh. So we will have a very excellent session. We had so far very nice presentations in the last 7 sessions, and now again we will have. So thank you, all of you, all the speakers, the organizers who are there in the this particular session, and all the audience who have listened carefully about this thing. Thank you all.